the digital solutions session. This event, as you can imagine, has been a long time in the planning, and we're really excited to have you here today, have your energy in the room, despite it being 8:30. I hope you've had a little bit of a caffeine hit. I certainly have. So the event, will run for the full day. You'll get the full welcome later on as part of the keynote. But we're going to kickstart the digital solutions session, and we've got a full day lined up in this session. Digital, as you probably well know, is an integral part of new processes and technologies going forward for materials and manufacturing. So that's why we've got a really exciting full day ahead of you. So without further ado, in this first session, we've got some exciting speakers, and we're exploring the opportunities and pitfalls for adoption of AI in materials and manufacturing. So by quick show of hands, AI, is it something that will change the world? Or is it just a marketing term? Oh, great. One of our speakers puts his hand up for that one. Yeah, I know. Okay, so obviously AI has been an increasingly hot topic for several years, and only seems to gain more and more attention in the public eye. And it's becoming increasingly part of our daily lives and catching headlines. But yeah, applications in materials and manufacturing are no different. There's some sort of very eye-catching headlines with millions of supposed materials being discovered by different solution providers. But some of these claims are perhaps a bit overstated. There is transformative potential for AI in this area. So what's the reality, though, is that the adoption of AI is still relatively limited in materials and manufacturing. There are several interconnected and complex barriers which hamper adoption. But in this session, what we want to uncover is some of those applications, some of those opportunities, and how some of those barriers can be overcome. So firstly, I'd like to invite Sharif up to the stage to talk about, he'll be introducing the recently formed Industrial Decarbonisation AI Coalition, or IDAC for short. Yeah? Sharif?
Hi. Can you hear me with this? Yeah, great. Thanks everyone for being here so early. It's the hardest session to be in, but it's also going to be the best one you attend all day. Just a quick background just on myself. So I've sort of been working in the machine learning AI space for the last 10 years or so, mostly around things to do with decarbonization and climate applications, but also a bunch of other things. So I was co-founder of Carbon Ray, which is a company that works in cement decarbonization, develop machine learning software for process optimization. And currently with Nexus Climate, which is a company working to support both startups and corporates on their decarbonization journey. We operate between London and Dubai, so both kind of UK and Middle East. And one of kind of the most exciting things I've been involved in the last year, well, in the last few years, has been setting up this with Chris and others, together with Innovate UK and others, the Industrial Decarbonisation AI Coalition. So we'll talk a bit about that today. Just before I start, actually, because I did raise my hand on both sides of the question, and it's not. I do believe that AI and machine learning have, are technologies that will change almost every industry, almost every aspect of scientific and technological discovery. But at the same time, there's so much hype around it today. So you kind of see some of the stuff that's coming up. If you're on LinkedIn, you just keep on hearing a lot of things. But 80% of it is nonsense, 20% is not. So it's just often just kind of seeing what's real from what's not. Okay, that's Chris. You've all met him. That's me and no picture. Okay, so yeah, what I'm going to be talking about is today is one of our main priorities as IDAC, and this is the development of a framework called AI data exchanges. And the idea behind it is to unlock the potential of AI and machine learning in industry, particularly for the purpose of decarbonization. If you think of what they are, it is a framework that we're developing currently, and hopefully over the next few months you kind of will be able to publish more detail and have more consultations and get more input into it. But essentially the idea is to see how we can get to the point where today there is kind of some successful but quite specific applications of AI and machine learning in industry, to the point where we what we've seen with language. It's gone from models that can do very specific tasks to foundation models that can do a very large variety of tasks and really be able to master language in a way that wasn't even imaginable maybe even 3 years ago. So what I would like you to think about in this presentation is what is the potential of foundation models for industry, for things like industrial processing, for things like materials discovery, for things like testing and simulation, and how we can get there. Very quickly, just on IDAC, this is a sum of our membership because it's grown recently. So we launched in December. This was kind of our inaugural membership, and we've had a few new members joining very recently. Still working on adding the logos, so that will happen very soon. But the goal of the mission, the goal of the coalition, is to bring together industrials, industry bodies, startups, research centers, to accelerate the potential of AI and machine learning in industry, particularly for decarbonization. Okay, so the challenge. First off, there's huge potential. AI and machine learning, I believe, have incredible potential in improving industry in general, and for the purposes of our discussion today, for industrial decarbonization. But there are limitations, so things are not moving as fast or as broadly as they could be. And I believe there's a few key reasons for that. One is data access. So if you kind of think of the development of LLMs, they were made with very large scale data from the internet. It's publicly available. Okay, they were not supposed to scrape it without, at least my view, without permission, but they did, they could, and here we are. Now, the good thing is, with industrial data, it's proprietary, it's private, it cannot be scraped, which is a good thing. At the same time, that means that we don't have these very large data sets that enable this transformative R&D. Then we get into how do we, what's the commercial model for sharing data so that data owners and technology solution developers both benefit. Industrial companies in generally, if you're a cement manufacturer, a steel manufacturer, chemicals industry, you know your stuff. You know how to make your products. You're an expert in the industry, but you're also not an AI company, which is a very different thing. And if you're an AI company, you know how to do machine learning. You don't know how to make cement. And it's like, how do you kind of cross that bridge? And yes, any company with a bit of extra budget can put together a data science machine learning team. If you're an industrial company, and they're going to do good stuff, they're going to be skilled people, do great stuff, they will not be able to become an AI company. It just doesn't work that way. So the I'm going to skip this slide because I have another one. I was supposed to have removed that one. So the thing I want to focus on is the commercial fairness challenge. And if we look at the comparison with what happened with LLMs, is that all the big publishers, kind of imagine all the big newspapers, the writers, all of that, put their stuff online, it's got taken, developed AI models with it, and then being now sold as a product without any compensation for the publishers. That's a problem, right? And if you're a company in the industry, you don't want that to happen. Obviously not, of course not. Now, so at the same time, you have, as McKinsey has been telling everyone for like the past 15 years, data is the new oil. Great. But, oil and, this, I know this is about decarbonization and climate, but forgive me for that one. But oil is great when you extract it and be able to do something with it. At the moment, it's in the ground, not doing very much. Now, so how do we do that? First, we have to have the incentives. So how do you share data in a way that brings benefits to the data owners and the technology providers and technology developers, and enable this kind of collaborative AI research and development. So really with AI data exchanges, the idea is to develop this kind of techno-commercial model that enables that data exchange to happen, those large data sets to come together and to be used for transformative R&D. But also to do kind of things around that. So, identify challenges, defining solution spaces, recruit kind of the different parties to, like the industrials, the startups, the research organizations, clean data sets, create them, and all of that. With the techno-commercial framework, the key to what we try and solve there is data pooling, profit sharing, governance and trust, and as well as the infrastructure support for it. That's just kind of to give a very broad overview of what will come out of that. So you have three types of organizations, really broadly speaking: AI companies, industrial data owners, and research centers. And on the kind of what we want to be able to get to is open research or commercial solutions that bring commercial benefit and IP to both or various sides that have contributed to developing it, whether from data or technology. That's it. If you have any questions, please do reach out at info@idac.org. Thank you very much.
Excellent. Thanks very much, Sharif. I think just a couple of things to say. So we have a workshop with IDAC coming up on the 11th of March. So if you'd like to be part of that, then come and speak to either Sharif or I through the course of the day. I forgot to say at the beginning, welcome to our online audience. This will be recorded, so you'll be able to watch it back later. And there'll be an opportunity for questions after all of the speakers at the end. So, but on now to David. Yes, thank you.
Good morning, everyone. So yes, I'm going to be giving a kind of talk on the work that we've been doing at MatNex and sort of building on the two other speakers here at Innovate UK. So just to start off, so yes, my name is David Papp. I'm a scientific software developer at MatNex. You can think of us as experts in materials discovery using AI. So basically, think of it as we have a platform, and right now, as we speak, it is discovering materials without me having touched a computer, right? So just one thing I'd like everyone to keep in mind, throughout the duration of this talk, just keep track of how long it's going to take. And there's a little surprise at the end I'd like to draw everyone's attention to, okay? So who we are, why we do things, and how we do things. So I think the way you can think about us, so we're 20 to 30 people, mostly scientists, and we concern ourselves with three main areas. So computational modeling, machine learning and data science, and then you have experimentation and engineering. I'm going to talk a bit about how that all comes together a bit later, but just keep that in mind. And so just as an example as to why we exist and what our mission is, right? So it was recently found, there's a lot of data on this, that the amount of time it takes for a product to sort of go from conceptualization requirement into an existing product that is then in the market being used is about 20 years. Okay, so 2 decades worth of time to get a new material into a product. That's quite a long time. And it turns out the reason for this, one of the biggest hindrances nowadays, is that in order to get a product to be, a material to be realized in terms of its properties, right? It requires people sitting in a lab all day, trying different combinations until they get to the right thing. Now that's, a bit of a brute force strategy, and we have basically pioneered a solution to bring that time down to 3 to 7 years, right? So a more than half reduction in the time for a material to hit a product market. And so just as an example, we've been doing a lot of work in the space of magnets. There's this kind of problem where if the trend continues as it does today, the future generations will not have access to any kind of electric motors. So if you think about electric vehicles, wind turbines, green energy in general requires rare earth magnets. And there's a lot of squeeze being placed onto rare earth magnets. Geopolitical tensions, running low on supplies. The amount of carbon emissions required to even mine them out is a concern. So, we said, okay, let's try and figure out a solution. What can we do with the platform? So we came up with a solution, and we came up with a new material called Magnex, which was purely the efforts of an automated computational platform. So we've put in constraints. We said, okay, we don't want rare earths in there. We want to minimize cost, obviously, and maximize performance, right? Because we don't want it to be weaker than the currently existing ones. And as you can see, we took about 3 months of developing these models into like an MVP stage. And within 2 weeks of computation on what I would call not an industrial-sized compute cluster, we got a viable solution. And by the way, that is an actual image of the magnet. So I'm going to go a bit back to kind of what I talked about earlier with like the computational modeling and what we concern ourselves with. I like to think that the way we do materials discovery is the ultimate, most infinitely scalable way. If you think about just a pure machine learning model, you have this concern that Sharif has also kind of touched on, which is ultimately your model is as good as the data you put into it, right? So based on what we have now, which is a lot of experimental results, which is great, we can come up with some interesting solutions. However, if we want to make this truly scalable, it will require more data. And so what we do at Matnex is not only do we make these AI and ML models, but we also make the data synthetically via high throughput quantum chemistry simulations, right? So you have kind of a circular system where the data is being generated, fed into these models, enhancing the predictions. And not only that, but we also will then test these materials at certain milestones in actual laboratories to validate our results. So I'm just going to talk through a really quick example. We're all going to do materials discovery this morning, just to show you guys kind of how this works. So if you imagine, let's just say, okay, I want a 4-element alloy, right? I want a new one. So we have 4 different positions, and we're going to concern ourselves, let's just say, with all elements on the periodic table. You now have 8 million combinations to try in a laboratory. Okay, so it's a bit getting quite big already. Now, let's now say, okay, well, we'll vary the percentage of each element within a resolution of 1%, and you end up with 1.4 trillion for all 8 million combinations. So doing this by hand is a bit difficult. Now, the question is then, okay, well, let's say we have all these simulations and we can compute all this. What do? We plot them, and we say, in this case, let's just say it's the carbon emissions of creating the material versus the performance. And we generate what we call the Pareto front, which is the best materials in its class with certain constraints in place. Now, if you think about it, this is a very simple example. We can add more constraints, so on and so on. But what we aim to do is we want to push the Pareto front down further. And we want to define a much clearer, much resolute frontier where we can then pick those materials and be like, oh, these are truly the best that we can get. So just to talk a bit about the challenges, we have this great system where we're getting all these materials. One of the biggest problems nowadays is that obviously the industry, being the industry, it's been around for decades. If I were to just give an example of the engine industry, there are more than 5,500 engine-related businesses globally that have been around, some of which for more than 50 years. They will have processes for R&D. They will have certain blockers in place where if we go to them and say, hey, there's this new material that is exactly what you want, but it's better in X, Y, Z ways, well, they'll say, okay, well, sorry, but this is not how we do R&D. So there's a bit of a reluctance to change here in the industry. Sorry? Okay, thanks. So that's one of the things that we kind of try to work around, and we're working with industry partners to kind of maneuver around this, but it's still very new to a lot of companies. So I just wanted to go back to what I said at the beginning. So yes, within this time of me speaking, the platform has automatically discovered 350 new materials that we have cataloged, calculated all the parameters for, and are probably being fed into an ML model as we speak. And maybe, very maybe, there's one in there that could be the next special material for something big. And I'm glad that all of you could have been a part of that, if that is the case. Thank you very much.
I'll certainly take some credit for that, David, if it is the next big thing. Okay, remember, questions at the end. So Bogdan up next. Thank you.
Yep. Thank you for joining this session. Bogdan, I'm a machine learning scientist at Intelligence. So what I'll be talking about is a bit of a practical approach to machine learning, how we actually use machine learning, what are the pitfalls, and some of actually the solutions we have discovered during our way. First, quick introduction. Who are we? We're Intelligence. We're a machine learning company. We offer a software to a lot of industries. We work in materials, manufacturing, life sciences, batteries, food, which is very interesting for me as well. What we offer, really, what we're trying to do is provide a software that's easy to use. So no-code approach for engineers and scientists that don't really know anything about machine learning, but are experts in the field. It allows them to leverage machine learning for their work. These are some of our partners we work with. We've been working in machine learning AI offering solutions around 8 years now. We have a large variety, as mentioned, of sectors that we've captured, a couple of integration partners as well. So, what is the challenge and what is the opportunity? Well, any process, such as material discovery, where you have new material, new process, you're recording things like composition, you're recording things like ingredients, you're recording things like processing parameters like temperature and so on. These all are optimizable processes, optimizable formulations. And of course, you have properties. These are the things you measure. These are your performances. These are your costs that you want to optimize, minimize, and so on. Or environmental impact, which is very common these days, that you want to minimize. So the standard approach to testing in a lab is to go and try things, brute force it. Go and you do these kind of design matrices that you try and minimize experiments, but in the end of the day, you still need to do a lot of experiments, a lot of trials. With machine learning, we take a different approach. We think about it differently. Well, if you can build a model on some of that data, then you can ask the machine learning to guide you towards that goal. You don't need to generate that many experiments. You don't need to go and do that many trials. You can just ask the machine learning a couple steps, it will guide you to the right point. So this is a case study that I would like to talk about very quickly, and I'll show you how we've actually used machine learning for it. So it's a very new case, which is funded by Innovate UK as well, which is open source. So we have printing, photopolymerization. So for those who don't know what this is, you might be very familiar with it from the dentist. This is plastics that harden when you expose them to light. The study case we did is for dental aligners. They are particularly challenging because every dental aligner is unique. They need very specific target properties in terms of the surface quality, in terms of the adhesion, how well it's built, and deformation. So then if they deform too much, of course you can't use them anymore, so you have to throw them out. So we want to reduce the waste. This is a process, right? A simple one here, we actually have a cake, but it doesn't really matter what this. The key here or to highlight is that you have ingredients, which is the eggs, flour, and you have some variables, inputs and settings, which in this case is your temperature control and time of the oven. This can be directly translated to how any manufacturing process works. In the case of the printing, of the polymerization, you have the printer, you have the photopolymer, and you have all these parameters you can control, like the UV exposure, the time of exposure, the heat after that of the process. However, they're very complex. We don't have only 4 ingredients for the cake. We don't only have eggs and flour. We have more than 50 various parameters. This becomes very challenging for a scientist, for a design expert to actually optimize, to figure out, to play with. And this is where machine learning can really help. So, the pitfalls. Any pitfall, I've heard that one so many times, we don't have enough data. This is not true. Any data, even if it's small, can help. We can learn things from it. In this particular project, we started with no data at all. What we did is 10 tests. We mapped up all the possible parameters that you can possibly control, all the ingredients. We did only 10 tests, and we figured out, put them on machine learning, figure out which were the key parameters, which one actually matter, so we can proceed with that. Second, pitfall number 2. Well, we need to test all these parameters, the entire design space, as I mentioned, the traditional approaches is to map out, do those design spaces. This is, again, not true. You can, once you build a model, even on these initial 10 tests, you can go back to machine learning algorithm and ask it, what is the best test to do? What is the one or few tests to do that will get me to my targets that I want? And this is exactly what we did. This has scaled quite badly. So the first thing you do is you ask the machine learning, okay, give me, based on those set of requirements, I want my scan accuracy to be more than 8%, and I want my process time to be less than 24 minutes for that dental aligner. These are my requirements. These are the requirements that come from a customer. Go and ask, we went and asked the machine learning, give me a set of process parameters to satisfy those conditions. We went, we measured, we collected data, we trained the model. It gave us those 5, let's say, new suggestions to try with combinations of process parameters, and we run them. If they weren't successful, that's fine. We just repeat the cycle a few more times until we succeed. It's proven so far many, many times that by following this cycle, you don't do hundreds and hundreds of experiments. You end up doing 20, let's say, out of 100. So the potential here for saving is anywhere up to 80% of your experimental trials. Pitfall number 3. My model is not accurate enough. Again, we've heard that one so many times. What I want to highlight is that as long as you have a model that's more than R squared of 0, so it's more than just random possibilities, then you can use it. Of course, the model will not be accurate enough if you only have 10 suggestions, but that doesn't matter. You have those confidence, you have a model that can guide you, you have some relationships extracted, and what we want to highlight part of intelligence very often is that confidence, the uncertainty that comes with that model is as relevant as the accuracy. Based on how confident that model is, you can guide where the next suggestion is. Thank you. So that's exactly what we went to did. As I mentioned, we started with 10 trials. We did another 10, repeating that cycle. As you can see, all the dental aligners that we tested. And despite not having the greatest model ever, it was, I think, 0.4 R squared, we actually managed to reduce the time all the way from 32 to 21 minutes and improve the accuracy from around 60% up to 90. So what that actually means for the business is that for 100,000 parts that normally take around 13 days to make, they took only 9 days. That with those savings and with better accuracy. So the potential for machine learning is that, okay, we did it on, I just showed you how we did it on one part, on one printer. But machine learning can be deployed. It can be deployed on any machine. It can be sent and to manufacture any site on any part. It's scalable. And this is exactly what we did. We integrated it in the machine. So now every single machine has it. Every single printer has it. Every single printer optimizes its part. Again, reducing the time, improving the performance. This is the final outcome of the project. Oh, so as you can see, it's this repeating that loop. You manufacture the parts, intelligence part of the cycle. We optimize them, and we deliver high-quality parts with reducing the energy output and the environmental impact. So, yeah, if you have any questions or you want to talk about it a bit more, please find me after this or have a look through our website. We have a white paper on this study as well, and I'll happy to have a chat. Thank you very much.
Thanks very much, Bogdan. I'll just flick back to the holding slide while everyone, if I could just ask the speakers to come and sit up the front here. We can take questions. Oh, this is going to take forever. I'll leave it on the intelligence slide. Okay, so there's an opportunity for questions in the room. So raise your hand if you've got a question. Just wait to get the mic before you ask your question. So there's one just in the front of the room here. Thanks.
Does that work? Yeah. Yeah, Gerhard Goldbeck from Semantic Materials. Thank you for your interesting presentations. I want to ask a sort of a general question to all of the speakers is how do we go from machine learning to real intelligence? So what we've heard here is some interesting examples of words like discovery, a process which is like a chemical process. You said it's a manufacturing process, but if you manufactured a bicycle, it would be a very different type of process. And then we have all of the data that are, for example, used in one specific context so that we can define them very well. But how do you then deal with data, especially also in this ADAC, for example, that come from very different sources, very different contexts, that maybe have very different labels? You said curation, yeah. But an intelligent system should be able to do that, to process that, where we hear about the large language models, where we hear about all of the other fields using knowledge graphs, ontologies, and so on. How do we move the materials field from machine learning to AI?
Okay, thank you very much.
I'll start. Thank you very much. So it's a really good question, really important question. I think it's just we're seeing this with large language models. We're not seeing this in kind of industrial applications yet. And I think there's I believe like we need to go to the level of solving the things at the chemistry and physics level. And within that, obviously, that's a really big thing. It's not saying we need to solve chemistry and physics. That's not something we'll be able to do anytime soon. But to kind of identify the specific things within those that are common enough. For example, we're talking about industrial heat or materials transformation on the industrial heat. What can be at least defined as a challenge? As a sort of a scientific challenge that's well-defined enough and has the potential of being solved if with the right data, with the right models, with the right R&D and skills, and then work on kind of removing the barriers to those. And some of them are data, some of them are computing, some of them are just getting the right people working on the problem and the right combination of people. So I think it's what I do think is I think language is an easier problem than chemistry and physics. Language is a much more various levels of abstraction down or up. I'm not sure which way, but essentially, I think when we talk about industrial processes, chemistry and physics are much more fundamental and harder to choose. But I think the other part of it is, potentially reimagining like the process of making something, because we're using the same processes in many cases that have been used for 100 years, sometimes 200 years, just with a bit more modern machinery, but basically the same thing. So I think that there's quite a lot to do there yet. I don't think LLMs will do them. We'll get there. Like they can help in some narrow parts of it, but not the whole thing.
Yeah, I think what Sharif said is pretty much how I see it as well. I think to answer your question, with more computational advancements, I think what we'll start to notice is that these models will tend to become more and more fundamental in terms of what they actually calculate. So like, to give an example, right now, a lot of models deal with anything that is nanoscale and up, but then they won't go below nanoscale. And I think the more computational power that we develop, Moore's law and that kind of stuff, the more we'll be able to go even further down into the depths. And if you think about it, if you simulate everything from first principles, well, that would be a true intelligence that you'd be able to get from that point, because it would be able to derive all the other properties, in the nano micro scale from the very first principles. But I think right now it's a bit difficult because we just don't have enough computational power to be able to go all the way to the smallest length scales and then traverse all the way up to the highest length scales.
I'll try and give a bit of the practical approach again. One of the biggest challenges we do in the machine learning is actually capturing the knowledge of the design experts, the engineers, the lab scientists, so they know a lot. They've been working on those new materials for 20, 30 years. So one of the biggest challenges is actually capturing their ideas, their knowledge, their constraints into the model. When it comes to LMM, they have knowledge as well. They have gathered a lot from the internet, from various books. So that's also information that we can use and we are using to help the model, to build the model, to direct it in terms of constraints. They're not, again, as Sherry said, they're not to the point of to be independent as a scientist, but no, they can help.
Thank you. Yeah. Next question. Yeah.
Thanks for that. I'm going to add on to what you've just said, and you've literally just hit, Bogdan, I think what I was going to ask, actually, but I'll go a little bit further. So there's so much hype, as you started with, in AI. I mean AI, by the way, but there's so much hype. And only last week, in the BBC, ChatGPT, there's massive question marks about hallucinations, and, people are going, wow, they can't do everything they say they can do. So we're all aware of that. You've, Bogdan, just mentioned involving the human expert decision-making in the process. And I think you started with Sharif. In your principle, I believe, is taking machine learning, developing, and then somehow bringing a network in of expertise, sharing that expertise, so sharing IP, which would be interesting, human knowledge. Where do you all sit with the responsible side of all of that at the moment? i.e., LLMs, let's just use LLMs, we talked about huge amounts of data being, it's only good as the amount of data you put in. If you put more data in, it's only as good as the more data you're putting in. So it's almost training itself on the data that's already in there, or you're adding more data, which can just create even more hallucinations and problems. So where do you sit with the responsible AI aspect of making what you do fully transparent? The process, the solution, the platform, and also the auditability aspect, because I'm absolutely convinced with the hype in regulatory industries, soon, because things are moving so quick, regulation will put massive guardrails where everything's saying, unless you can absolutely show transparently exactly what you're doing, and you're going to hit your 99% or 100% success rate versus it's great we've saved from 13 days to 9 because we're not being massively successful as such. I think that will transform AI and what we do with AI at that point then. Has that made sense? Sorry. So the responsible AI, transparency, auditability, I suppose, and involving human expertise is my question. Where do you all sit with that?
There's a lot to go after there, I think.
No,
but it's a good question.
I'll just about add on that one. It's a bit of a trade-off. So you can use the public AIs, the ChatGPT, they would know a lot, They will have access to all the internet, but of course, anything you share there will be shared. It's not private. What we do is you can trade for something local. You can use elements from your machine or server, or make your own secure environment that you can guide into checking only documents that for this particular company, for this particular client, customer. That would, of course, has a limitation. They would not know everything, but it's guided, it's secure, and it still help you as an LLM to summarize the information, guide you to the next steps, how to use machine learning, how to use kind of have like an assistant. So it's a bit of a trade-off there from my point of view.
Just going to make a prediction, which is always dangerous, but I think by the end of the year, we're going to have quite a few scandals of companies that have put in too much trust in LLMs and resulted in pretty problematic things going on. I use ChatGPT all the time, but I know what I'm using it for. I know its limitations, and I'm very careful with that. I think, in a way, in when you're talking about manufacturing settings, there's two aspects. The aspects where you're using things like LLMs for things that are decision-making in maybe at a corporate level, and I think those risks exist as they exist in any other industries. The other side, which is often is a completely different type of machine learning and AI, when it's around process improvement, around material discovery, all of these. I mean, in a way, we're lucky because in two ways. One, often there's almost no private personal data involved. So like privacy risks sometimes go even down to almost zero, and sometimes zero. And the other one is that you're experimenting. Like by definition, you're trying things out, so you can validate things in real life before kind of going into full-scale production. So I think in many ways we're lucky in that context, but of course we do need to do it still, be responsible in developing it.
Yeah, thanks very much. I think what Sharif said is our view as well. Is that we, like, for example, at MathNext, we're very naturally skeptical about the sort of data that we train models on. We're very careful with making sure that we validate the data, that it's not anything incorrect or could lead to some malicious results in the future. We're very careful with doing it step by step, and we really try to scrutinize all the way through how that works. Maybe also just to add, we with all the models that we do, I would say they're very containerized. So I think we're a bit far away from having like one single ML or AI model that is all-knowing about manufacturing materials, how to make them, that kind of stuff. It tends to be a bit more like we'll have a model that predicts a certain property, and that's pretty much it. But then we'll have a collection of these that kind of work in aggregate to get us where we want to be. But your question is very important pertaining to the future, where we see more and more of this kind of like agentic thing that's coming out, where it's like we wanted to be able to do everything under the sun. Now, I think that's certainly a concern, and I think we should be cautious about trending towards that direction. Yeah, thanks.
Okay. Well, I'm conscious of the time, and we've reached the end of our allotted time, and I know that we've got a tight turnaround between the next session. So at that point, I just want to thank the speakers again, and thank the audience as well for your good questions and your attention as well. But yeah, we'll move on to the next session after a quick interval to change over. So thank you very much.
Welcome to everyone, both here in the theatre and those joining us online. My name is Chris Needham. I'm your chair for this session, Harnessing the Power of Shared Data. I work in the Made Smarter team at Innovate UK, a team whose focus is inspiring new and novel digital innovations to support a world-leading manufacturing ecosystem. One critical strand of our focus is how we can harness the power of digital across all manufacturing businesses, including the vast landscape that includes SMEs, small and medium enterprises, of all shapes and sizes. And that's where one of our Made Smarter Innovation hubs come in, the Smart Manufacturing Data Hub, a £20 million investment which is focused on how SME manufacturers can better acquire, analyse and act on data within their businesses, and also working with technology developers, such as designers of sensors, and how that can help these manufacturers in that acquisition challenge, how bringing together different data sets from different SME manufacturers and supported by access to data analysts and algorithms can use that increasing pool of data to make better decisions. Today we have two great speakers from that one linked activity. We have Justin Quinn from Ulster University, who are the lead partner in the cross-UK consortium delivering the Smart Manufacturing Data Hub, and Tim Telford from DevTank, a technology developer and solution provider that's funded through those hub activities, have developed sensors that connected through the platforms that the hub have built, empower people to make better informed decisions. Assuming that we finish on time, there will be a chance for a couple of quick questions. So please do make a mental note of anything that you'd like to ask, and we can either pick up at the end or grab any of the speakers during one of the breaks throughout today. So, on our journey from better data through faster digital to insightful decisions, there should be something hopefully for everyone. Let's kick off with Justin.
Thank you, Chris. So you're all very welcome here today. Thank you for attending. And what we're going to do over the next 20 minutes or so is take you through some of the setup that we had and what we wanted to do in the programme and how we make the move from where we are in industry at the minute to a data-informed industry, a data-informed manufacturing industry. So we have to realise the value of SMEs manufacturing data. Lots of SMEs have data that perhaps they use, perhaps they don't use, perhaps they realise they have, or perhaps they don't realise they have it. And navigating through that to ensure that you get the best decision making within your company is something that's really, really important. Large companies, the 5,000 employee companies, have the bandwidth to be able to do all this, but SMEs are a different type of company and have different needs and different requirements. So the project really, the pilot that we ran as Chris introduced it, aimed to look at that, aimed to collect the data and aimed to get something from the data. So I'm going to run you through what we did over the past 3 years. So look, we tried to pull together a range of skills within the consortium, and that has to look at industry bodies, R&D, tech partners, and commercial solution providers. And you'll hear from one of the tech partners that came on board, Tim Telford from DevTank here. And Tim will illustrate to you what probably the back end of the project is and what the practical application of the project was. So what is it we want to do? What's the challenge? The challenge clearly for industry at the minute, and government drives this and has driven it over the last number of years, is increasing the productivity. Does that mean more for less? More from less? Well, certainly, if I go locally to Northern Ireland, we have a serious requirement for people, serious requirement for engineers, serious requirement for production operatives to meet the targets that we have for production. We don't have enough people, and there's not enough people coming into the industry. So we have to look at how we can make ourselves more efficient. There are things like supply chain disruptions, skill shortages, global competition, and the drive at the minute toward a move toward net zero. All of that captures data. Whether it's capturing a skills audit for your business, whether it's capturing an output number, or whether it's capturing the movement of your goods and the carbon credits or the carbon load associated with that. All of these important facts are things that are within your business that must be monitored. So how does a manufacturer keep up with the dramatic speed of global technological change? AI, the implementation of ChatGPT, all the tools that are available now weren't really so available at the start of this project. So there's a massive change between the start of this project and where we are now. So what did we try and do? Well, the idea is to grow data-driven businesses. What is a data-driven business? Data-driven business moves away from the older way of doing it, where you had very experienced individuals making decisions based on some data and a lot of experience. We don't have so many of them now, so the data is really important. Looking at things like, how do I make more accurate predictions? How do I have higher operational efficiency that drives cost savings? It's important that we gather the numbers around that, and it's important we have, as Tim will talk about, it's important we have the technology to be able to gather that data in the first place. And what then is the final or the best outcome of that? And that is sharing that data. That's sharing it to learn from one another. I will give you the part of the story at the very start. Whenever we started to develop this program, we talked to a lot of industrialists, and we posed the question to some of them to say, if I could walk you around every factory in the UK, would you learn something? Would you get something from that factory? Of course you would. You would see how they do things. You would see how they manage their processes. You would see the different parts of, you would come away with something. Do you have the time to walk around all the factories in the UK? Definitely not. However, collecting the data, sharing it, illustrating it, and supporting this sort of low-cost digitalization to gather that data in the first place allows us the chance to have a window into multiple businesses across the UK. So you can see where you are in terms of your productivity. We can benchmark a company that manufactures steel items in Redruth in Cornwall against a company that manufactures steel items in Elgin in Scotland or Antrim in Northern Ireland. So there's lots of things that you can do. The fundamental part of it, though, is collecting that data. And the outputs from it are some of them are illustrated here. You can see high-skilled workforce, a different workforce than we have at the minute. So let's have a look at the components of the program. We can see here the sort of transition that you have from where we were, which was potentially data-rich, but unknown quantities of data in businesses. And putting together the platforms that we had in the program, then we could begin to first of all collect that data, illustrate that data, maybe dashboard it in some cases, and then to look at the data analytics and draw insights from it. So we had a number of different sections to the program, including a virtual manufacturing platform, a manufacturing data exchange platform, the data analytics and insight areas, and virtual modeling and digital simulation. Let's have a look at the manufacturing data exchange platform, MDEP. MDEP was the repository where all the data was held for the program. What this allowed us to do was this allowed our data analysts to look at the data from lots and lots of companies and at the very simple level, do things with that data. That could be visualizing it. It could be making it clear for a company so that you're not wading through spreadsheets. Or indeed, it could be looking then to try and draw relationships from disparate parts of the data that are within your set. So across the program, you could see the different sections that were available there. And if you look at the very bottom, you had some underpinning foundations there. And these are really important, particularly the skills part and particularly the learning platform that we had, because the skills to do the data collection, the skills to analyze the data, aren't really prevalent in SMEs in manufacturing at the minute. Now, I think that's changed quite a bit over the last number of years, but it's something that we must continue to push within the companies. And our learning platform and the courses, the online courses that we have available for SMEs, free to SMEs, are really, really good to get a start. So let's look at the impacts and let's look at some of the benefits. When we look across the UK, you can see we wanted to build a nationwide network of test beds. We wanted to look at how we develop this data community within industry. And to that effect, obviously, Tim's going to speak here as one of our lighthouse projects, where he had certain challenges in his lighthouse project that he'll probably talk about. But what it did was it began to bring technology to industry where it may not have been there before. It de-risked the implementation of data collection within an industry. So if you think for an SME, the most important thing in an SME is generally, do I get my product out the door on Friday? And if we then say, well, I want you to measure this, I want you to measure that, I want you to measure this, do you really have time for it? You need to have a really good case to say, yeah, I'm going to set aside time to do something different, time that could potentially affect my ability to get my product out. However, with our program, with the implementation of Tim's technology and other lighthouses and other demonstrators that we funded across the UK, and you can see the distribution of them, that allowed companies to de-risk that decision. It made it easy for you to adopt that technology and realise the benefits of it. And what do we provide? Working with companies, we look at that move up through the levels from exploring right through to innovating. And some companies will move up that rather quickly. Some companies will take more time to move up through that. And some don't really need to get to the innovate level. You just need to get to the explore, the understand, and the connect level to learn from each other. What are the challenges? Well, you look at that and you go, without data, you're just another person with an opinion. I have lots of opinions, and that's great, and it's entertaining, but the data is the thing that discerns whether you're going to get the right answer or not. Numbers. I think it's a great idea. Well, very good. You think it's a great idea, but what's the numbers behind it? And that's part of the data. So those challenges, I'll not go through all these questions, but if you have a quick scan over them, you can begin to see the sort of questions that are driving SMEs. Where do I invest? Can I try it before I buy it? What are the steps? How do I get there? How do I bring people with me? What training do I need? What's the level of investment? The program addressed all of these. And you can see in this rather populated slide, you can see all the areas of the program. And what we wanted to do was move companies from the start, where you had data-driven business support, right through to that innovation and accelerators and incubators and looking at low-cost solution development, which we really did. We have over 700 sensors out in industry at the minute, and some of those are multiple sensors, so they're measuring lots and lots of data across lots and lots of companies. So we had to understand the users as part of it. And I think for any SMEs that are listening, or any SMEs that get to see this, it should ring true with you. Some have no data at all. Some have some data, but it's not really used properly. You can think pages that sit at the bottom of the tray that are never looked at. I equate it to my children and taking home their homework that usually sits in the bottom of the bag for a long time, is never used. It's there. And then you have lots of data, where we have a company with lots of maybe disparate data, maybe data that comes from many, many different sources within the company that can be in many different forms. So how do we make sense of all of that? We take them for that through this journey, through the exploring, looking at a website that we had, taster sessions, a virtual hub, but then looking at other things like roadmaps. How do I move from no data to some data to a data-driven business? How do I then implement that? Do I need sensors? What sensors do I need? Can I collect the data from maybe existing machinery? Can I collect the data with a very small sensor? It could be just a temperature in an oven. It could just be a pressure. It could be air quality, or it could be power that you're using in a process. Many, many things can be measured, and that's probably one of the straightforward parts. Doing something with that is then more difficult, and that's where we look at the support and guidance aspect, looking at master classes, at boot camps, and working with companies to develop things like training pathways. So if we look at the skills challenge, who is responsible? We have all these different types of engineers and many more in process at the minute. And where do we want to get to? If we look at why we don't excel in manufacturing, and I think we do in some cases excel in manufacturing, and I think certain areas of the UK punch well above their weight in manufacturing, but we can be better. So we need to find out who's responsible. Who's responsible in SMEs? In a large business, you can have lots of different types of engineers. In SMEs, it's probably very few. So when we look across all the different areas, then what we can do for our skills, is look at what the digital roles are in the companies. We can look at our learning approaches. And we did all this as part of the program. And developing those skills and embedding those skills within a company is key to growth and key to embedding data within the companies and data within the decision-making that takes place for investment, the decision-making that takes place for maybe new product development, maybe looking at getting more out of machines that exist there at the minute, maybe getting a higher productivity overall, or indeed maybe hitting sustainability targets that you haven't been able to hit or you're unsure of what your numbers are. So while there are lots and lots of aspects to it, in each of these, one of the really attractive parts of the program was that you can take small parts of it. You don't need to do it all. It's there for you to take at your leisure, but you don't need to essentially engage with the whole part of the program. So our academy worked out then really well, and you had programs of learning there, first line leaders, lean was there, project management, all the things that are useful to industry, and we tried our best to make sure that these practical approaches to learning gave enough to improve businesses, but not so much that it became a chore to try and learn. So when you look at it, and maybe this robs one of the questions we talked about, Chris, so sorry about that, but it is difficult to make a start, and part of our program was really driving businesses to make a start. You know, don't spend your time looking, don't spend your time thinking, am I going to do this? Make a start. You know, if we were American, they would say fail early, fail again, fail early, and eventually come to success. And there's a part of that in this, but facilitating it with support from the team across SMDH and looking at all the things that we could offer from robotics right through to manufacturing test beds was something that, again, and I'll stress this, de-risked the decision-making processes within companies. So within that then, we were encouraging low-cost digitalization. And this is where things like DevTanks technology and other companies that we had on board, we wanted to provide a way for companies to be able to engage without having to make a massive investment. Try before you buy is a lovely concept, but sometimes try before you buy can mean you're not getting really the quality of technology that you need. What we did was we worked with different companies to provide reliable, supported technology that allowed you to assess your business, that allowed you to assess how you would implement further once you'd gone through the initial processes. And what do you want? You know, if we look at it, forecasting and predictions really important within businesses. We've worked with a number, everything from manufacturing heavy steel items right through to the food industry, where you're beginning to look at prediction. You know, how many parts do I need to make today? How many parts are made in winter time? How many parts are made in the summertime? When's my most popular time? How do I schedule my business to suit all that? Data, again, drives that. And the goal here, I suppose, at the very end, is to look at automated decision making. Can I have enough data? Can I have enough intelligence in my system to automate my decision making so that I can do something else with my time? So, if you look at what the sources are, and we establish this data pipeline, all the sources within a company, you can list them out there: sensors, IoTs, energy, legacy data, process data. All of these have to go, come from different areas. Our Excel spreadsheets, the mighty ERP systems that lots and lots of companies put in place and think they're going to solve all their problems, and they spend lots of money on ERP systems. And it is a kind of a bugbear of mine, but spend lots of money on ERP systems and then don't put the data into the system to get what you need out of it. They're very, very good when they're used correctly, but they can be troublesome when they're not. Look at paper systems, probably even worse. Sensors, wireless devices, logs, and the manager's head. And what we get from those systems is the ability to look at management and control, compliance, condition monitoring. Now, condition monitoring is about for quite some time, but it's not really taken up so much in SMEs. It's more a large company. Condition monitoring and predictive analysis for things like bearings, things like motors and all is more likely to be found in a large company than a small company, and there's no reason it can't be in our SMEs. But when we look at it then, we have those different data levels. So you can begin to see how we navigate through the data pipeline there to go from raw data on the shop floor and manufacturing data right through to business and how it links to the business. Let's have a look at a use case. So this is a company that we went to at the very, very start. And you can see standard manufacturing company. They make a lot of aluminium items that go on door surrounds and barriers around doors. So not a really complex company. CNC machines of various vintages, which Tim maybe will comment on. Various machines of various vintages have limited access to data, and you have to append something to it to get your data. So what we wanted to do was we wanted to monitor the power consumption of their CNC machines. What would that do for us? How would you gather that data, and where would this start? These were the questions that the company had come up with. So what we did was we developed a very simple power sensor to monitor the energy used on the CNC machines. The sensor was linked up to their network, and live data was generated. So immediately, you can log into your web page or whatever portal you have and look and see, is my machine switched on? Is my machine drawing current? Is it drawing the same current that it was drawing yesterday when we were making the same item? Is it being used for long periods of time? Has something broken on the machine? You can begin to ask questions about the performance of the machine that previously, and I'm simplifying it away down here, but previously you would have walked down onto the shop floor and seen if the and-on light was on. You would have walked down to the shop floor and hit a few buttons on the screen to collect a piece of data. Now you don't have to. So we did this with the company, and that began their digital journey. Within that then, we had a number of challenges, obviously developing low-cost sensors, looking at how you would gather that data, what the different levels of it were. How do we make this for a very, very small amount of money so that we can distribute it to companies to allow them to use it? Now, the challenge then was how do you measure this? What do we use? Do we use CTs? Do we wire directly in? What levels of current do we have to measure? What's the normal? Are there outliers in the program? Is it worth measuring something that's 800 amps or 1,000 amps when 90% of the companies are somewhere between 100 and 150 amps per phase? Okay. So what we did was we compromised somewhat, but we made sensors then that would allow us to do that. These clip on over existing cabling for easy use, and they connect to the cloud. They connect to the cloud and transmit the data that you can use then later on in the process. And this is the sort of thing you'd see it out at our stand if you want to take a run around to see some of these sensors in action. But this is the sort of output that you're going to get. And if we look along the bottom of the screen here, you can do a range of things. That fingerprint of manufacture can represent products. So immediately, once you've got that fingerprint of manufacture, if that fingerprint changes, something has changed in your process. We don't know what yet, but soon you will. You can look at overall consumption. We can look at calculations for products per time. We can detect cycles in production, and we can calculate the consumption per product of power. Strange things that happens with this sort of measurement. You can begin to see things like a tool breaking on the machine because you see a loss of power. You can begin to see different workers and how they operate the machinery, what time it takes for setup, and so on. So obviously collecting that data is useful, and energy, I suppose, ended up being one of the most useful things that we were collecting, because most companies only look at the energy bill at the end of the 3-month period and suddenly discover I've spent a lot of money on it. Doing that live and having that ability to assess your energy profile makes it really, really useful, and automating that makes it even more accessible to companies. Up-to-date insights that you can action before you get to the final, before you get the big bill, I suppose, at the end of your period. So we developed a program online, an application that allowed us to do that, and we could look at everything from your base load to outliers, looking at abnormally high consumption periods. We could see what was called phantom energy. And critically, from this, you can look at costs, and you can begin to see what can I do within my company that will reduce these overall energy costs. And that's the key part of it. You can look at distribution for different days, and we can begin to see a real insight into how we manage the energy within our companies. And that has knock-on effects for production. It has knock-on effects for many other areas within your business. So by analysing the machinery, we can look at things like, as I've said, machine utilisation, product identification, cost or unit energy price analysis. We can do a range of different things. And again, that's available for every company and is now an automated process. Just giving you, I suppose, I don't want to go into the technical parts of it, but you can begin to see the sort of traces that you get from the machine. Okay, traces that you get from the machine. And it allows us to identify idling thresholds, switched on thresholds, overall power, and so on. So what do we offer? We can identify that energy. We can measure the impact of actions you take to reduce energy. And that's something that's important. And that can be transferred over to different areas of your business. So the company that I introduced, now they have started their digital journey. They're better informed for their business decisions. The analysis of that data has been really insightful. It gives them clear benchmarks to work from. And the company also joined a training course provided throughout the project on the value of this data. So I'm going to hand you over to Tim Telford. And Tim was a lighthouse project within the program from a company called DevTank. And Tim's going to give you a few minutes on what they did and how they were very successful in the program. Tim, thank you. Thank you. Yes.
Thanks, Justin. That was really, really good. I've seen that one a couple of times now, and it's still interesting every time on just the level of things that we can do to help SMEs. And it starts off quite simple. It doesn't have to be too complex to get going with this technology and to start learning what you can do with data. So I'm Tim, CEO of DevTank. We're a small SME based in the Midlands. We develop smart sensing technology and monitoring and measuring solutions for manufacturers primarily, but we work across sectors. I'm going to talk today about why data is so important to your business, and I want to put ourselves in the footsteps of a typical SME manufacturing kind of business leader and some of the pains that they're experiencing, and this is kind of systemic across the manufacturing space. So imagine a world where data drives your profitability, productivity, and also helps you with your sustainability goals. That's the world that we want to live in, right? We want data to do these things for us. We're trying to empower people to make informed decisions and stop the hunch. Historically, a lot of businesses are driven based on hunches. The business owners have got an idea of where the problems are and what they need to work on and resolve, but they need data and science to back up these hunches, and that's what we're all about. Just a little bit about my business. So we started in 2014. We've got a couple of brands, Hilltop and Open Smart Monitor. I'm going to talk really about Open Smart Monitor today, but Hilltop, just briefly, is focused on helping manufacturing businesses with automated testing. And we do a lot of PCB level testing and end-of-line test solutions. You can see some of the brands and the names we work with. We work with lots of different sizes of business, from micro SMEs all the way up to blue chips. And we've got some really good alliances and partnerships with Ulster University now and the University of Derby. And we're also related to or associated with Raspberry Pi. We've been using Raspberry Pis for a number of years. So we've got a design partnership with those guys. Just very briefly, this is our management team, myself, co-founder Joe, who's our sort of software guru and expert, technical expert, and then Martin was actually one of our customers, and I convinced him to come and work for me a couple of years ago when he sold his business. So Martin's got years of manufacturing expertise he brings to the table. Right, I want to talk to you now about Edwina. So Edwina runs Edco, a manufacturing business in the UK. She works tirelessly to keep the lights on and keep the business moving in the right direction, but she has a lot of sleepless nights. Like many business owners, myself included, utility costs are rising. She's worried about retaining staff and also recruiting new staff. Employment costs are going up year on year, which is a problem. How can she do more with less? How can she be more productive with her team? On top of that, she's got equipment breaking down and failing. She's got, like many businesses, full of historical, established sort of legacy equipment. Can't afford to replace it. You've got to keep it running, right? And then the final nail in the coffin really is she's got all these net zero pressures to start thinking about. She's got our customers asking her to, basically provide scope 2 and 3 emissions data. And this is on top of trying to run the business and keep it all going smoothly. So I can feel her pain. She's got a lot of pain. In the UK, there's about 270,000 manufacturers, and about 90% of those are SMEs, and they're all suffering these sort of common pains and sicknesses. We've got, according to some stats from the ukmanufacturer.com website, I think 77% were facing rising energy costs. I think this slide's already out of date, to be honest. I think this was last year. And I suspect more than 34% want to improve their energy efficiency. I think it's probably more like 80, 90% want to improve. And then 180 billion was lost in 2023 on productivity, and this was due to equipment outages and downtime. Sick building syndrome is something some of you may have heard about. So this is where if you're not on top of your sort of environment, in your premises, in your factory, staff can start to get sick. The building itself can start to get sick. It's not a good optimum environment for people to work in and for productivity to improve and to get maximum output. So you've got to really monitor your environment as well as things like energy, utilities, gas, water, etc. And net zero, I don't need to say much about that. I think we all know that that's sort of something we all need to take very seriously and start thinking about. So if Edwina had a sensor in her hands that would allow her to monitor a business holistically, wouldn't that be great? Well, she could have one of our sensors and she can start to actually see where all the energy is going. She can install these things, and I've got one here somewhere. Forgot to bring it with me. Here we go. So typical sensor that we install across factories. And this is like a Swiss Army knife, so this would give you all your energy stats, all your environmental information, air quality, temperatures, humidity, gas, water, and it starts to give you useful insights into things like machine monitoring and predictive maintenance as well. If you've got, let's say, an energy profile for a machine tool, you can start to really drill into that and analyse that and find out what you can do to maybe work a bit smarter, to turn that equipment off when it's not being used, that kind of thing. Maybe you want to fit some vibration probes on it. And so just to recap, the value of data, it's really about trying to identify opportunities for improvement, to try and do more with less, to try and minimise our waste in our business and our operations, and reduce carbon from our operations. And really, it's about trying to find problems before they occur and make ongoing improvements. Now, our solutions were deployed last year through the SMDH project, and we rolled out about 350 sensors across the UK to around 50 SMEs. And a lot of them started to find some useful insights already and started to make step changes and improvements in their business. We anticipate 30% kind of savings on operating costs in the first 12 to 18 months, and we're in some cases, some of our clients are seeing more than that in terms of improvement already. Our solutions are open source, they're vendor agnostic, which means that you can actually hook our equipment into legacy machinery and legacy systems. You can suck the data out of existing meters, energy meters on your site, or old CNC machines within reason. If there's technology there that we can hook into, we will. It's not about necessarily replacing everything with new tech, because that's not sustainable and it's not cheap or easy for a lot of clients to do. And obviously productivity improvements go sort of hand in hand with all of this monitoring and sort of, you know, smart analysis that we're starting to do. So benchmarking, we're going to talk a bit more about benchmarking. When I started this project with SMDH and MDEP about a year ago, I don't think we really understood the value of this until it happened. So we started to get lots of bakeries coming on board and quite a few woodworking, joinery type businesses as well. And it sort of dawned on me that wouldn't it be great if one bakery could kind of look at another bakery, another competitor's data and understand their energy profiles and their kind of carbon emissions and the whole shaboodle, you know, environmental performance, and then work out if they're on track, are they above or below the competition, because that's really important, right? You want to make sure you're trying to stay ahead, and someone told me recently, I don't have any competitors, I just have collaborators. And that's particularly kind of important in my area where I work with a lot of open source technology. But it got me thinking. Actually, sharing is caring. We're not asking you to give your IP and your crown jewels away to the competition. We're asking you to benchmark your business at a top level with another same sector business with similar outputs. And I think you learn a lot by doing that. And that's the value of the MDEP project and SMDH as a project and consortium. Data is king, and without it, you're flying blind. And it's the old measure twice, cut once, which, you know, we all like and acknowledge. Just to finish off with a couple of quick case studies. So Vanzi runs DPS, which is on the Welsh borders. They manufacture moulds for the chocolate industry. And they work with a number of sort of high street food chains that you'll know and recognise. They've got a lot of our sensors monitoring key pieces of equipment and assets in the factory, such as CNC machines is a big one, and a lot of companies we work with have some kind of machine shop with large heavy-duty pieces of kit that consume quite a lot of energy, and it's kind of interesting to profile those and try and work out what you can do better. Can you turn them off? Can you work them harder? That kind of thing. So she's making improvements already to her business. And then we've got Stephen, he's the chairman of Pentaxia, and that's a composites material business based in Derby in the Midlands. And they're really doing this on steroids. They've got not just energy monitoring, but also environmental monitoring. So they've got a number of clean rooms, and they've got chillers and freezers where they have to keep the composite material, the raw material, at an optimum temperature, an environmental spec, and if they don't keep it at that temperature, that stock can get spoiled. You know, we're talking hundreds of thousands of pounds of stock here that has to be maintained at the right environmental, parameters. So some of these things I'm talking about are not just about ongoing improvements, are also about quality control, about making sure you reduce your wastage and you stay on track as a business. I think that's all I've got today. I've only got 10 minutes, but hopefully you kind of get the idea about what we're doing here and the larger SMDH, MDEP projects we've been involved in. I'm on stand 35 with the SMDH team if you want to come and have a chat today. And I think, have we got time for questions? We've got any questions in the audience?
Yeah, if you can just stay up here. Tim, Justin, if you want to join us at the front. So firstly, thanks to both our speakers. Lots of great insights there, and thank you particularly for bringing it to life with the real-life case studies. We've got a couple of minutes, so delighted to take any questions. I've got a colleague somewhere with a roving mic. Sherry, where are you? Come back. I've got a roving mic. Any questions? Happy to take them. We'll use the microphone just for the folks online. It's easier for them to pick up.
This is a quite interesting topic, the shared data of industry. So how do we make sure that to all the industries to share this data, because the data is a new oil, right? How do you collaborate with the industry to get it in the common pool, the data, the manufacturing data?
Yeah, well, I'll make a start at that. I think the important part of it is we have to do it step-by-step process. So measuring is the first thing that we need to do to establish the baseline of data that's there. And I think within any company, that illuminates a lot of the issues around your manufacture. Naturally then, I think with any company, the next question is, well, where am I? Where am I against everybody else? So if we approach a company and immediately talk about shared data and immediately talk about sharing your data, that tends to slow the process down. The process we've used is to come into the company first, collect the data, illustrate to the company the usefulness of that data, and a natural step forward then is to begin to see how everybody else is using their data. The sharing part within our overall program wasn't a problem at all, and that Tim's example of the bakeries, we have some bakeries in Northern Ireland that have shared data as well and done this sort of benchmarking process. I think as time goes on and you establish more companies measuring more parts of their process, we'll find then that sharing that data and the development of repositories like MDEP becomes more and more normalised.
I was just going to add to that. It's a two-pronged attack, really, as Justin said there. Start with actually looking locally at your business and make those step changes and those incremental improvements. And then, the extra nugget at the end is, golden nugget is, oh, by the way, we can compare ourselves to all these other companies in the same sector. And it's like a double whammy of benefits there. It's not just local monitoring, it's then wide-scale monitoring within your sector, almost.
Thank you, folks, and thanks for the answer. We're almost out of time, so I'm going to wrap up there. I appreciate there are a couple of questions, but we're on a tight timeline for the next session. So if I can ask you to hold those questions and grab the speakers outside. Thank you, everyone. I hope you enjoyed that session. The next session starts in here and indeed in all the theatres at 10:10. And then from 10:55, there will be a pause in all the theatre sessions for about 15, 20 minutes. Gives everyone a chance for a break to see the stands, the exhibitions, the demonstrators, including, as the guys have mentioned, SMDH with Justin and colleagues, and DevTank with Tim and colleagues have got stands out in the foyer. So thank you very much indeed. Good morning. Thank you for joining us today. Warm welcome to everyone, both here in the theatre and those joining us online. My name is Chris Needham. I'm your chair for this session, which is Driving Sustainability Through Digital Solutions. A very quick intro. I work in the Made Smarter Innovation team at Innovate UK. That's a team who's focused on inspiring new and novel digital innovations to support world-leading manufacturing ecosystem. One critical strand of our focus is how we can harness the power of digital to improve the sustainability within manufacturing. That's either through enhanced process understanding and visibility to reduce energy draw, so less electricity, gas, water, etc. And also to optimise control through more efficient control of material usage, and thereby optimising our use of materials and reducing the physical waste. And both those acting together so that we pull in less of the Earth's resources and we put out less CO2. Today I'm delighted to say that we have three great speakers from three very different projects, but all with the same goals. One of those projects is from the portfolio of projects that's funded by Made Smarter Innovation Programme, the programme I work on. And we've also got two from two other key programmes that also lean into the opportunities that digital solutions can bring. We have Ming Yang from Cranfield University, who will explain the role of digital innovation in carbon abatement. This is a Research Council funded study, so earlier stage research, driving sustainability and also a circular economy, and the digitally enabled business models that can spin out of that. We then have Olatunde Banjo from MTC, that's one of the catapults, who've worked closely with Harrison Spinks, they're a manufacturer of luxury mattresses, to bring in modelling, measurement, data analysis and high-tech control into very traditional engineering processes. In this case, it's wire drawing, so the drawing through the wire that makes the springs that then sit in the Harrison Spinks mattresses, to significantly both reduce energy draw and setup scrap in their case. And then finally, we've got Richard French from i3D Robotics. They're a developer of intelligent vision systems. And Richard's going to bring to life a number of digital tools within a really interesting robotic inspection project to reduce waste in the foundation industries. So foundation industries are sort of base materials, glass, cement, ceramics, steel, things like that. Assuming we finish on time, there will be a chance for a couple of quick questions, so please do make a mental note of anything that you'd like to ask, and we can either pick that up at the end or grab the speakers in the breaks that ensue. So, from our journey today through models, mattresses, and then Richard melting things, there should be something for everyone. Let's kick off. That's enough from me. Let's kick off with Ming.
Hello, everyone. My name is Ming Yang. I'm a reader in sustainability at Cranfield University. Today, I'm going to talk about my research on how can we use digital technologies and business model innovation for sustainability. First of all, let's look at the UK industrial decarbonization strategy. So currently, the UK industry produces about 70 million tons of CO2, and we want to achieve net zero by 2050 through 6 ways. And here, the green part is REEE, standing for improving resource efficiency and energy efficiency. And the orange part, the largest part, is hydrogen. And the yellow and the dark blue part, they are relevant to CCUS. So what I want to highlight here is really in the next 10 years, most of the carbon reduction is going to be achieved through improving resource efficiency and energy efficiency, and which accounts for about 13 million tons of CO2. And if we break down the 13, we found 9 of them comes from resource efficiency and material substitution, and 4 comes from energy efficiency. And we know the resource efficiency is largely achieved through circular economy. So this tells us a clear message that circular economy plays a very important role in achieving net zero 2050. Another really important point I want to make here is that our research finds that the green part, REEE, is actually underestimated. We think that REEE actually has the potential to reduce much more carbon emissions in the industry. And more importantly, REEE is cheaper, faster, and safer compared to those expensive decarbonization technologies. So this is our latest paper. The figure on the left-hand side, that's representing the current typical government policy. And the REEE takes about typically 18% of total reduction across all. And from our case studies, we found that actually REEE has the potential for reducing at least 50% of all the carbon reduction, and largely through those simple actions like turning the machines off when you are not using it, that kind of thing. But then you might ask, then why is REEE overlooked? Why is it underestimated? We found one of the reasons is that inefficiency, especially resource inefficiency and energy inefficiency, is invisible. It's kind of invisible waste. It's hard for us to see it directly. And so if you want to improve your REEE in your company, you really need to be really good at seeing waste and reduce waste and turning those especially invisible waste into value. And this is where I think digital technologies and business model innovations have important roles. Because like digital technologies, like in the previous presentation from the previous session, it was digital technologies can help us to visualize those waste, energy waste, resource waste, and also help us to see waste much faster and more precisely. Here is like an example of the companies that I worked with a few years ago. This is a digital twin of the factory's production line, showing the working performance of each of those different job stations in real time. So can you see waste here? So basically, the green part means working, it's good efficiency, and the rest of it is waste or inefficiency. And and the interesting thing is that this system was built by their digital team, and they didn't see this kind of waste at the beginning until the time when they started to work with their operations managers who have the expertise of lean production. So then we found that if the digital providers and those domain experts, they work together, they find a lot more opportunities of generating value for their business, especially for this kind of resource and energy efficiency areas. This piece of research shows how digital technologies can be used to achieve different circular economy strategies. Like there are 10 R strategies of circular economy, and we identified 13 digital functions which are most relevant to those circular economy strategies. And we mapped them against each other. So basically the size of the dots represent the studies, the number of the studies we identified from literature. So this map kind of shows like there are a lot of studies going on in terms of reduce, rethink, and repair, recycling, and these are the circular economy strategies that are most accessible to digital technologies. And there, you see there are a lot of dots here in reduce. It also indicates that the current most effective or mature studies of using digital technologies is actually to achieve reducing resource and energy consumption, and that's very relevant to REE. I'm going to skip here. So this kind of map also shows a bit of like the future research directions. For example, one of my observations was that there are quite a lot of studies going on around how to use sorting and the classifying function to recycle products. But then there is almost no studies about using that function for repurpose, reuse, repair, which are often more valuable than recycling. Then I wonder why. Then we looked deeper into this and we found one of the critical reasons is that lots of end-of-life products, they end in a mixed waste stream, so that the kind of products which have the potential to be reused and repaired, they are contaminated in the process of the recycling, and therefore they had to go to the recycling stream, which is the least valuable way. And this kind of gap leads to our current project, our new project, looking at how can we how can we prioritize the repair and reuse and make the circular loop a little bit tighter by developing a robotic system to do the circularity triage. So here we propose this new concept of circularity triage, referring to rapidly examining the health condition of the reused products and make a decision in terms of which circular strategies you need to take. Back to the framework, we also developed further into like a practical guide to help companies to develop like a digital strategy for circular economy. And I want to very quickly introduce business model innovation as well, because we found in the digitalization process, digital technology is really important, especially in terms of supporting circular economy and REE. Just a quick example. So this is one of the world's largest manufacturer of gas generators located in China. And gas generators are the machines like this. They separate air into different industrial gases. And this company has been transforming their business models and trying to be more circular. At the moment, they have 4 different business models, and let's see how different circularity they are. So most traditional business model is like selling, making and selling products, very linear, as you can see. And their second business model is like selling products, but in addition to that, they provide some services like repair and maintenance, which is very common as well. And there is a bit of circularity going on there. And their third business model is a user-rented business model. They rent their gas generators instead of selling them. So since they rent it, they have the ownership of their products, so they have the incentive to recycle, reuse, and remanufacture their products and maximize the value of their products. And as you can see, it's more circular than the previous business models. And this is where digitalization plays a role. In this business model, because they own their products, they rent their products, and they can, it's easier for them to install sensors for their products and collect data during the use of their products, and therefore it's easier for them to make use of the data from their products. Their most interesting business model is this one, result-oriented business model. They sell their gases instead of gas generators. So what they do is that they build a gas center inside of an industrial park where their different customers are located, and they supply different required gases to their customers. So they are not only reuse and remanufacture their gas generators, but also the gases, optimize everything. So this is not just the most circular business model, but also the most profitable one, and it's also most digitized one. So my observation and the last point is that we found from our research that servitization makes it easier for digitalization. Because especially if you own your products, you can basically digitize your products a bit easier. And second, digitalization in return, it can make better services, because service is very often intangible, and the digitalization helps you to provide optimal services. And across the whole process, the ownership of product and the ownership of lifecycle data is very important. And that's all from me, and I'm going to hand over to our next speaker. Thank you.
Thanks, Mian. Good morning, everyone. My name is Olatunde. I'm just going to carry on from what Mian has talked about and show you some practical examples of a project that we did late last year. It finished, and it just shows you the power of digitalization. Very quickly, I'll just preface that by saying that depending on where you are on that journey, even if you don't have the right data, the right tools, you can still embark and start today. So the project itself was sponsored by Made Smarter Innovations, and it was about sort of looking at how we can use digitalization to reduce material loss and improve efficiency. So I'll talk you through a bit about where I'm from. So I work for the MTC. I'll give you an overview of that, and I'll talk you through the project. And then some of the solutions that we did, and we have a stand outside where you can actually sort of have a go at some of the work that we've done. So very quickly, to give you an overview of MTC, so we've been in operation for quite a while, of just roughly over 10 years. And we're an RTO, so based in Coventry. And our main purpose is to sort of sit between that academic work and applying it into research. We've got a few technology teams that I'll introduce to you in a second. But overall, we have several ways of engaging with industry and engaging with research. Moving on very quickly to the project itself. So the key partners were Harrison Spinks. So they are, I think the light's in my eye. They're a luxury bed manufacturer. And yeah, they have a few tools that they make themselves. So they're very innovative in their thinking. But the digital element of their work was missing, and that's where we came in. We also had a company called Bax that sort of worked in that sensor region, so helping us to harvest the data. And I'll talk you through how we started from the journey of no data into some data, and then some of the complex models that you can do with that. So overall, the main objective was to sort of look at that process. And I think this is something that the MTC does very well, to understand that process and leverage some of the partners that we have to sort of understand the process and then build the digitalization layer on top of that allows us to do complex analysis. So as a bit of introduction to what really wire drawing is in the real sense, in case that's far from you, it's basically taking steel rods and pushing them through a die at some speed and reducing the cross-section of it. So overall, one of the key things that Harrison Spinks is able to do very well is that they're able to draw this to fine wire. Now, if you're scientific and you're thinking, you'll appreciate that there will be some friction in terms of that loop process that is happening there. And if you're making fine wire and having to make them into coils, if you haven't treated the material properly, you can very quickly start to experience fracture, which is a lot of waste. And that's where majority of the waste comes through. So the process itself, like I said, Harrison Spinks acquired, I don't know the sheep, but they were not part of the project. But Harrison Spinks actually get the materials from the bedding from a real farm, which is really interesting just in terms of what Ming was saying there about the circular economy. So all the materials are kind of reasonably sourced, if you like. I'm not sure the sheeps like it very much. But the key challenge was that it was very labor intensive what they were doing. There was a lot of waste. And because there wasn't any visibility, we couldn't stop that until we were trying to make springs and found out, actually, we haven't drawn them correctly. Yeah, the sheep actually moves. So why did they come to the MTC? Why were we partners on this project? As I mentioned before, we work with a wide range of digital technologies, so this is something that we do excellently well. Personally, myself, I'm from the modeling and simulation team, so we do a lot of assessment, but to be able to build complex models, you need data. And if you don't have data, then you don't have a model. So it was very challenging when we approached Harrison Spinks because they were not data mature, but we were able to work from sensor installation, sourcing the right type of sensors that they need for the right type of data that we need to build the kind of models. And then on that layer, you start the basic things like process control, because sometimes on the journey to digitalization, you don't start with the complex models, it's understanding the process and knowing, hey, change this and change that. And the solution approach itself, so we started with a bit of measurement. So we have some of my colleagues back in Coventry who do a good non-destructive type of testing. So the dies that convert the steel rods to the fine wire, we sort of measure the roundness. So there's a couple of things that could happen. So first of all, the die, if it's not aligned properly, could wear or could lead to damages and cracks, which means you will have quite a bit of changeover and a lot of manufacturing efficiency. But more importantly, it could also have impacts on the wire itself, so you wouldn't get good quality wire out of that process. So one of the questions we set out to answer was, can we actually measure that? And can we predict the life of that die? So what happens practically in manufacturing when you can't see is the operators will comply to the best practices that they can make do of. So what was happening was they were just making changeovers to avoid damage because they figured out, well, if I change it a bit early, then we have less waste. And what that meant was they were changing tooling unnecessarily. So in terms of the process itself, so the figure 6 is what you're actually wanting to have in practice, where your wire is straight on the eye of the die. And one of the things we want to do with the demonstrator is to challenge you. I'm not going to do it here, to put that steel rod through and make sure you get that particular sort of angle. So it's very difficult. So what would happen in practice really is more what you see in figure 7, and there's variations of that. So variations of that means that you generate quite a lot of heat. So depending on how variant your setting is, that's the kind of wire that you're going to be pulling out. And because you don't realize this until post-process, it generates quite a lot of waste. So one of the things that we wanted to do was to understand what was actually happening. The second thing to be mindful of is there is some lubrication that is needed for the process. So if we can't test the lubrication, we can't tell whether the angle's right. The only thing we can see is, oh, that wire is bad, so a whole ball of wire is sort of being wasted. So from some of the results that we had, and as you will appreciate, there are some challenges with measuring some of the dies. So we couldn't get the probes to go through the core of the die, so we had some missing data. So we tried to use the CMM machines just to explore, what's the wear profile? You know, can we start to use artificial intelligence to understand what that profile is looking like over time, depending on the angle of incident? And from the measurements, we identify that we couldn't fully capture some of it. Now, there is that line there where we have missing data, which means we don't really know what's happening. So we can see the wear on the die entrance and on the exit, but there's a band in the middle that we couldn't quite figure out. So one of the things that came out of this project is to explore, can we use AI? Can we have, you know, models that we can use to understand what's happening within that core, if we can have more flexible probes to sort of see the profile of the wear. So in terms of next steps, I'll fly through very quickly. We've got some collaboration with some universities. We're still working with Harrison Spinks to try and develop a process where we can measure the dies in process. So if we can actually see what's happening with the wear, we can sort of predict changeover times and save them a lot of efficiency. We can also start to look at, you know, second life for the dies, because they're all in stages. So we can't say, well, this die is worn out for this step, but for that other step, we could still reuse that die, and we can make the argument for it with the right data. So in terms of what's the value of digitalization, why should we really do it? You know, before we met Harrison Spinks, they were already making beds. So what is the big deal about what we're talking about? Is it just about sensors? Is it just about getting data out and doing something fancy? Some parts of it, yes, if you're a geek. But overall, there is some value in digitalizing your process. So these are some of the results. I won't go through them all because I'm pressed for time, but these are some of the tangible results that Harrison Spinks were able to realize. And because they've never really sort of measured data this thoroughly, as soon as we started measuring, the benefits were really obvious. Before we started the models, they were already reaping the benefits. So sometimes we often think that digitalization is until something big happens or you have a complex model, but in some cases, it's just starting with measuring the process. It's starting with talking about the basics of what you're going to model, and you can see that the change within the culture starts to be seen. So this gives you an overview of some of the things that we did within the project. So there was no process data, and now they've got live monitoring that they can see what's happening, and that's already a win. So before we start to get to the complex models, they were already winning. So just running through very quickly, we brought a physical demonstrator with us. So that's what the wire drawing line itself looks like. So this is currently based at the MTC, and I've managed to bring figure 14 with me outside so you can come and have a look. So what we've done is to bring the physical process and prototype it very quickly. And with that now, because we've got the digital assets that we can use to run the production, so on the one stand, you can see the physical thing, adjust your settings, and then you can get the digital feedback to sort of see how you're aligning your die. And I think very quickly, that's everything I have to say. But in conclusion, I think it's really important, the journey to digitalization. And one of the things that I want to summarize and say before I pass over the mic to Reed is that the digitalization journey starts with the first step. And that first step is understanding your process. And you don't have to wait till the end of a complex model to get to your digitalization journey. Thank you very much. I think I'll invite Richard to come and talk to you from...
Thank you. Clicker. Awesome. All right, thank you very much. So I'm going to talk to you about our TFI project, Irifio. Essentially, it's robotic inspection for a multiple cross-sector plant demonstrator, but a little bit about us, i3D. We're a micro SME based in Kent, and we develop both hard and software around machine vision, integrated robotics, and other integrated sensory technologies. The majority of our partners are multiple sectors. We really don't mind who we work with. We work aerospace, Rolls-Royce, defence, other people I can't mention, glass, metals, ceramics, healthcare, bioscience. We all have a little bit of a role in each of these sectors. Originally in 2019, we had a very good idea that we'd be able to translate some work we've done in metals inspection. This was hot rolled steel and wire drawing into other sectors, and this was targeted towards the glass and the ceramics sector. Ceramics being heavy clay, so that's brick and tile manufacturing in the UK. And what we decided to do was use the visual or the machine vision based technologies, or in this case, stereo vision, and integrated spectrometry to look at glass failures which occur through nickel sulfide inclusions in glass. That effectively means that there's a tiny little blob of nickel sulfide in the glass. When it's fired, nobody notices it. When it goes to toughening, the glass panel explodes. So those of you that are seeing glass panels just explode mysteriously on their own, 9 times out of 10 it's nickel sulfide. Upshot is that if you save a ton of scrap glass, that gives you back about 4 gigajoules of energy. So that's, in layman's terms, 640,000 cups of tea. It's a huge amount of energy to melt the sand needed to make glass. Conversely, the brick sector, embodied carbon in a UK brick is actually very good. It's about 0.46 kilos per brick. I can't tell you the wastage numbers from all our partners' factories, but if you optimise brick sorting, just so actually things look right to the human eye and avoid pallet rejection on mass construction sites, you save about 1.46 kilos per square metre of brick laid. It's huge, and that is just the firing. That's not transportation or rejection or materials. It's the energy that goes into firing. And then lightweight aluminium castings, slightly different sort of way of analysing this. This is replacing steel components that would otherwise be weighing an absolute ton in automotive, so you get a lot of carbon benefits the other way. How does this link to digital technologies? The photograph on the left gives you an idea. The UK industrialised a long time ago. Our infrastructure's old. Automation in the UK is old. These plants from all our partners on this project have been instrumented to death. Commercially, there's not a lot of low-hanging fruit left to look for and how to optimise with digital technologies. So we're really chasing niche markets. But the idea of this was to basically use the same core technology to gain industrial symbiosis. And we've used machine vision, spectrometry, machine learning, advanced computing techniques, supercomputing, all the way through to CAD/CAM manufacturing, and plant automation, plant controls, robotics, industrial, collaborative, etc. It's a huge integration project. Geographically, we've been spread across the UK. You can start to see a flavour across the UK of where sites are located, sort of digital sectors in the southeast and northwest, and also manufacturing sectors that generally spread from the north through to the Midlands. And what we're actually looking at doing was really ambitious. 7 sites, looking for loads of different defects in 3 different products. So we've got brick, well, 4 different products: brick, roof tile, aluminium castings, and glass. Therefore, that meant that we were trying to redevelop each core technology multiple times over by retuning the software to suit the application. And the challenge with a lot of machine vision data or high resolution data and integrated sensor data is the fact that when you're looking at high production plants, like say brick manufacturing can produce up to about 200,000 bricks a shift, you're going to be getting a lot of data. So originally our vision systems were generating about 1 terabyte an hour, and through the use of machine learning optimization, understanding how to reduce bandwidth through our partners, and trying this out using supercomputing facilities, downgrading onto standard computing, so that's about 900 watts of power used, downgrading again onto sort of laptop style computing or tablet computing, so that's 228 watts used, and then eventually running on embedded processing, which takes no more than 5 watts. We've got our own power consumption right down, At the same time, our data bandwidth has followed, and we've reduced it and reduced it and reduced it as our software has become more efficient. This was basically done with machine learning and layers of building up layers of neural networks for automated defect recognition. The only problem is our timing was a bit off. At the same time as these projects were launched, gas pricing went through the roof. So for a lot of partners, the objective was how to keep the light on in the production plant, not necessarily how to make it better. That theme has continued throughout the duration of this project, but things are slowly stabilising. And what we did is we've had to basically adapt and learn, go with it. It's not quite the ideal what we wanted, but we give examples of the plant from previous experiences in machine learning, all the way through to what we'd actually developed on this project. And essentially, a lot of it was basically visual identification defects through machine learning. Hours and hours and hours of manual training. This is really, if you like this sort of stuff, I don't, I'm a bit more hands-on, but if you like this stuff, great, hours of labeling, and it works very much in the way of any sort of vision-based project. You have to have thousands of the same instance to get confidence that your data set is robust, so that when you see the defect occur, so in this example, this was looking for brick chipping, you know you've got a reliable output. In some instances, with our partner for aluminium casting, we'd only got 25 instances because they make 250 products a year for a bespoke sports car manufacturer. That's where we had to get clever and start understanding how to be able to manipulate the data, but then start getting the same digital result back every time. And effectively, we built up layers and layers and layers of neural networks for each application. And ultimately, put it into practice. So somehow, through the just sheer effort of the team, this came together in the last few months. And we've managed to complete 7 installations, subtly different instruments, same technologies, different software, different approach to the learning. But it's all relied on the basic core data of colour, machine learning, and image recognition. And through the colour, we've been able to normalise background environmental light, so we take true colour every time. If you look on this photograph next to me, you can see there's a skylight and a little bright light peeking through. For any normal colour measurement, that would throw the system completely off and render all your machine learning useless, because you wouldn't be able to accurately predict a threshold of where it is. For a manufacturer, that could actually mean that the person normally inspecting the object, in this case a brick or a roof tile, might actually bin an entire batch worth. So you're potentially scrapping loads of products because you've got a subjective measurement. By normalising the background environments, you get a true measurement, and therefore you get 100% inspection. And this has prevailed throughout. Effectively, now we've got these plant installations up and running, we're in a bit of a race before the project completes at the end of the month to manage to capture enough data to build our confidence in the machine learning. And I think, this gives you some more working examples of understanding colour, glass defects, thermal imaging, looking at how all of our partners basically use energy to heat. In the brick industry, it's to heat water and clay. Your clay needs all the water gone. You can't do it too quickly because otherwise your product cracks. You can't do it too slowly, otherwise it stays damp. Optimal thermal drying times also applying to the casting industry. How to make complex moulds for aerospace. Take 60 to 600 hours to make a complex mould. If you can predict the drying times of that accurately, you've suddenly reduced the amount of manual labour going back in, you can make moulds faster. And then also, the nice result was sort of the middle photo right at the bottom, actually managing to make full colour representations of complex castings with 200 micron defect accuracy that meet the CAD model. And we can predict dimensionally whether this conforms, doesn't conform, or let the operator cheat and slide a few through that they know will be okay. And having that ability to give human-in-the-loop control of the digital process or the digital inspection has allowed us to move forwards. This is an example of some of the software that we've created for the project, where we're looking at, in this instance, for cold spots on the bricks. The UK is a really traditional industry. We like our bricks, and they've never ever changed for about 120 years. And if you make a brick look differently to what it should look like for 120 years ago, people reject it. So this tells you exactly what your performance levels are. And where it's drawn us round to is actually we've then been able to take these core technologies and apply it to integrated robotics to work in tunnelling environments, radioactive environments, build more accurate digital twins and supervisory controls, and also translate this into healthcare. So we've had a huge number of spin-outs from this project. And obviously, stereo vision manufacturer, I've got to get the advert in. Don't be a clumsy Cyclops. Thank you very much for your time.
If you want to just hold on to the mic, Richard. If I can ask the three speakers to join me up here. Ming, Olatunde, Richard. Let me just check on time. Yep, we're good. So thank you to the three speakers. I thought that was super rich in terms of what was shared there. I've been banging the drum for 5 or 6 years now about the role of digital in sustainability. I thought it's fantastic to see the range of digital tools that have been applied there, different levels of AI and machine learning, vision systems, modelling. I can't remember who was on one of those slides, but organisation I was talking to yesterday using the augmented reality to help see things better. I know now that digital is such an underpinning tool. And what I particularly liked in lots of those examples was it being applied to really traditional industries. So Harrison Spinks, mattress manufacturer, I didn't know them before this project. Really love the organisation. But it's fantastic. They've got a lot of modern equipment, but they've got some really traditional equipment. I'm going based on the colour of the paint here, but I'm guessing some of it is 50 to 70 years old, and they've brought in BACS and MTC to digitalise those processes. Fantastic. So we have a little bit of time for questions. Any questions in the audience? We have a roving microphone. Thank you, sir.
I have a question for Ming. Impressive presentation. As a climate impact fund, we do see our investment opportunities that way, both in addressing net zero goals as well as the commercial proposition of the business itself. Your point about that the more circular the business is, the more profitable the business is. Did you take that into account, the investments, like return on investment into kind of setting up new facilities and the marketing into a new market? So that's the first question. And second question in regards to your research, are you looking at different sectors as well?
Thank you very much for your question. It's a really good point. So for that, my point is not like all circular business models are more profitable. It's just in that case, the circular business model, the servitized, the most servitized business model is the most profitable one. And the last time I talked to them, 70% of their profit is actually from that business model. And you are right that it requires quite high investment, especially at the beginning, because it's entirely different revenue model. You you have much longer time to get back your investment. So this company, they actually had the idea of selling gases a long time ago, like before 2000, but they only managed to really develop this business model when they managed to go public, so that they have more cash to actually do the investment. But in the long run, very quickly, it became the most profitable one. Sorry, what's the second question? The different sectors. I mainly look at manufacturing sectors, industry. So it can be different sectors, and the same kind of servitization. Actually, it's happening more and more, even in glass industry, and like a refill business model. In the future, in the very future, perhaps the glasses what we use, they are not recycled. They are not just recycled. They might be refilled. You use the same bottle multiple times before they go to recycling. That kind of business models start to emerge more and more in different sectors.
Thank you both. And I think we can squeeze in one more quick question, if there is one. Sherry's an expert in AI, but training in microphone roving. So.
Cheers. It's a question probably for all three of you. If I've got rubbish, noisy data, can I do anything with that, or is it always worth me trying to put a lot of effort into getting that data a lot better?
So I think when you start to talk digital, that's one of the barriers to entry that is thrown in your face about the quality of the data. And personally, whilst it's true from a scientific perspective, I think that as human beings, we leave digital trails anyway. And I think you're the master of your own process. So even though your data is noisy and we can get that clean through digital tools, your entry point is understanding your process and being able to map that. The digital layer is an enabler to something that you're already doing. So for me personally, I think there is the hype about data, there is the hype about digital, and I'm a geek myself, so I enjoy that kind of stuff. But as a manufacturer at heart, fundamental is the process. I can cook rice. I don't need a digital tool for that. But I might not be efficient. The data then gives me visibility. If it's not right, you can employ that digital cleanliness. But fundamentally, I would say that it's your process and you own that. So controlling that for me will be the first step, and then the digital becomes an enabler.
Yeah, I think just sort of looking at it more from a commercial perspective, look at the playing field. You've got data, therefore potentially you're head and shoulders above the rest. How you clean it up is irrelevant. If you've actually got that source that's producing the data, you can do something with it.
Thank you, folks. Thanks for the answers there. We are right on time, so thank you for everyone helping there. Thanks, everyone, for that. Hope you enjoyed the session. There's now a pause. I'm 90%, 100% certain that there's now a pause in proceedings for about 15 or 20 minutes, opportunity to take a break, see some of the great exhibitions out there. The best two are obviously Richard's I3PD and Olatunde MTC. Lots of other good exhibitions as well. And then the next session almost definitely starts next door, 11:15, with the keynote speeches for today. Thank you for your time.
Online as well. Hope you've all had a really good day today so far. So my name's Philippa Glover, and I've just got a couple of minutes just to talk about Made Smarter and some of the background. So for those of you who don't know me, I have been involved with Made Smarter pretty much since the start, and have been a member of what was the Industrial Strategy Challenge Fund for Manufacturing for Innovate UK since 2019 as a member of their Industrial Advisory Board. And at that time, I was the managing director of an SME robotics business. So this topic was very close to my heart and really quite passionate about how could we collaborate both with government, policy and innovators to really support manufacturing in the UK, not just to thrive, but make sure that it was digitally enabled. So I just wanted to give you a bit of a background, or Chris asked me to give you a bit of background around where did Made Smarter come from. So for those of you who don't know, Made Smarter was an industry-led movement, and it was an industry-led review that was done in collaboration with government to really look at how do we help manufacturing businesses really reach their potential through digital technologies. It was led by Professor Jürgen Meyer, who was the former CEO of Siemens, who worked in collaboration with industry, both small, medium enterprises and large multinationals and technology providers, to look at what we needed to do within the UK to really accelerate adoption of digital technologies. The output of that review was published, I think it was in 2018, if I remember correctly, and led to a pilot which was done within the Northwest, accelerating adoption of industrial digital technologies within SME manufacturers. And if you read the review, I think a lot of its recommendations are still very much true today. And the three I wanted to just draw attention to was about skills and culture. And we've heard quite a lot in a number of the different talks today about innovation is great, but if we haven't got a skilled workforce that is capable of moving it forward, then actually the innovation can't necessarily deliver its return on investment. The Made Smarter review identified that what we needed to do was work together to really develop next generation skills, but also support existing manufacturing leaders working within UK businesses to really be able to develop their business in a digitally enabled way. That is still very relevant, and there's still a huge amount of work that needs to be done. The second area that came out of the Made Smarter review was around adoption, and that's about how do manufacturing businesses adopt existing industrial digital technologies and ensure that they drive the productivity and enable the future. And there's some great work that's being done and really looking at how do we supercharge more of that. And the third area, which is the topic that we're going to be talking about today, was around innovation. So how do we ensure that we have an active innovation ecosystem that really supports the development of next generation technologies to really ensure that the UK remains at the competitive advantage? And this is the topic that I've been involved in, and it's really easy to sit on the other side of these groups and often be quite critical of some of the things that are happening. And if I reflect on the journey that Made Smarter Innovation has gone through, there's been a huge amount of work that's happened behind the scenes to actually build holistic programs that have really helped be pioneers of the future. And for me, one of the celebrations of the Made Smarter Innovation kind of work has always been Innovation Alley. So those of you who go to Smart Manufacturing kind of week, you know, what you see at Innovation Alley actually is often the output of the great work that the Challenge has done to support those innovative tech startups and scale-ups and SME businesses really develop their products and services to support the next generation of manufacturing. And that's, for me, what this is about. This is about supporting SMEs and ensuring that we really have an active ecosystem that really is fit for the future. So that's just what I wanted to say. And, you know, those recommendations that came out of Made Smarter are really still very valid. And as we move forward to the next kind of phase, and as Stephen remarked in his opening address and keynote speech, that the government is currently now working on a 10-year industrial strategy. That is absolutely welcome, and Made Smarter forms a fundamental role as part of that to make sure that we not just continue the work that has been done, but also supercharge its impact to ensure that manufacturing really reaches its true potential in the UK. So I will now hand you over to Jonathan, and he will provide you a bit more background and context.
Philippa, thank you very much, and good afternoon, colleagues. It's wonderful to be here, wonderful to be with you, and to really celebrate the progress that we have made in the Made Smarter Innovation Challenge. I've been very fortunate to be involved in it for the last 18 months or so, and so there's an immediate acknowledgement of the depth and the breadth of work that's happened before I was ever involved in it. this sense of skills adoption and innovation as three strands that actually do intertwine, and people often use the phrase triple helix in a slightly different context, but they're all there kind of woven together in all this. I'm going to do about another 5 minutes, and then Chris will actually sort of give you some of the details. That's where we're going with this, and I hope I have some slides to kind of click onto. So I'm from EPSRC, Engineering and Physical Sciences Research Council. We are not the UK's innovation agency. We're the kind of UK's basic science research agency, but we are one happy family under a UKRI banner. And it's with this sort of shared hat on that I've been involved in the challenge. The challenge has funded 5 research centres in universities, for example, in addition to a huge amount of collaborative R&D. So just to kind of set some sense of scale, I'm going to whip through the slides quite quickly. I'm not going to pull out all the details. I am around all afternoon if you have questions on those. People online, you can find my details. And send me awkward questions. So it's about a 300 million investment over roughly 5 years. A lot of that co-investment coming from industry partners, and so a real sense of pull for what we've been trying to deliver. And I just thought up front, I'd sort of give you the scorecard, okay? This is entirely unaudited, I should make that clear. It's before the kind of formal monitoring and evaluation has been anything like completed, but a sense of, in black here, what we said on the left we would deliver, so 30% up to is a very good phrase for those of you who read budget statements, up to 30% productivity improvement, 2.3 billion gross value add, 4,000 jobs, 5% reduction in CO2 equivalent, 25% reduction in waste. So there's a sense of digitalization plus resource and energy efficiency, again, going together. And then just pulling out some kind of initial findings. These are median average values up to a maximum value. That these are sort of roughly in the right ballpark. So obviously it depends what your program is, but 7 to 65% productivity improvement, 15 to 50% reduction in CO2 equivalent, 10 to 60% reduction in waste, depending on the task at hand and the factory setting and so on. So a sense of actually we have delivered what we thought the challenge would do. The challenge, of course, is only scratching the surface of this as a problem. But in terms of what we said we'd deliver, I think we are there and we will celebrate that. So a sense of a collaborative ecosystem, as I've hinted at already, there's a sense of partnership here with our industry partners, large and small. There's a really interesting idea that actually this is much more about people than it is about tech. Tech we can do, okay? Particularly EPSRC, if you'd like a blue widget, we can fund people to make a blue widget. We can get an enhanced blue widget. We can get a lighter blue widget. But actually, if you don't have that culture change in the workforce, probably you're not going to get the adoption, the diffusion, the take-up of these compellingly adoptable solutions. And the sense of actually this meeting the productivity challenge, the way that we want agility through manufacturing, and we want sustainability. And with that, the sense of actually bringing the workforce along with us, and more than that, that sense of empowerment that they are actually given choices to make, and we use all that wisdom that is out there already. How we do. So there's too much detail on this slide, but it just gives you a few highlights. Okay, I can't really pull out much from the collaborative R&D. If we've supported 76 projects, you know, it would be invidious to pick a favorite child at this point. There's 30 million gone into innovation hubs. Particularly, there are 2 that I want to highlight here, digital supply chain hubs. So we can do much better in passing information along up and down supply chains. And smart manufacturing data hub, we can do much better when we empower SMEs to be able to share their data and learn from each other who are having very similar experiences, potentially in entirely non-competing sectors. And then over on the right-hand side, some other details of the research program and these digital accelerators that we funded as well. So a wealth of activity around the Made Smarter Innovation Program. And then just to kind of blind you with words that I know you cannot read, we put this on a wall at Smart Manufacturing Expo, and it did really well as a wall backdrop for things. It's less good on a slide, but you can pick out, you know, companies large and small and universities large and small from that. So again, just to reiterate some of the kind of outcomes: productivity increases, reduction in CO2 equivalent, reductions in waste, a sense of actually there is some tech development in here, so there is some innovation, and a number of those new industrial digital technologies that have been developed through the program, and then that sense of diffusion and adoption as well. And so you can clearly see some sense of the trajectory that we've managed to put at least the sort of the surface layer of the sector on. So there's plenty more of this afternoon, and I just wanted to pick out these three. So there's a session in the Donington one, which is sort of directly opposite us at the other end of the hall, where Sherry and Tim are going to talk through supply chains in the context of the program. And then you've got competing things for your attention at 4:10. So this is 3:20, where you can either have a session chaired by Philippa again, which is back in here. So one option, there's always a do-nothing option. If you stay in your seat for the next hour and a half, interesting stuff will come to you, okay? And in fact, the same applies online, I suppose. And then there's a session again in the Donington 1 room on the medicines manufacturing challenge, which is also part of what we've been delivering. So there are some exhibits around, and I thought the logos made quite a good slide. So the people-led digitalization aspect, we have really welcomed the fact that this is co-working across Innovate UK, EPSRC and ESRC, so the Economics and Social Science Research Council, and that sense of bringing together a number of the core capabilities of UKRI as a family to actually talk about these different elements and how they are part of the challenge. This is reflected in these three research centres who are presenting. The smart cobotics people have some robots that kind of dance and do other things. And then there's also our smart manufacturing data hub here with a suitably enormous logo. And so the evaluation is ongoing, but the draft kind of findings from this, just to pick out three, we've got within Innovate UK and the rest of the family, tried and tested collaborative R&D ways of investing. Those seem to be a good foundation for the further development of this, given that we have to reach about 270,000 manufacturing firms. Eventually, we need some mechanisms for that. The governance has been effective, and these social science and people-centered aspects have actually sort of slightly surprisingly perhaps come to the fore. If I were a social scientist, I would not be surprised by that, but I am not, and so I am. We've had a very large number of collaborators. This has been wonderful, and there's a sense of actually a direction of travel that enables us to hit a number of these targets that we have all at the same time, which is obviously what we need to do. It's no point picking them off one by one. In terms of where we go in the future, and indeed there's a real sort of influencing job for us to do on government, there is a lot of under-digitalization, a lot of low-hanging fruit still available. There's a need to sort of have that culture change to make these compellingly adoptable, and a need to get this to give us the productivity and resource efficiencies that we want to see. And indeed, in terms of the tech space, there's a real acceleration in what might be possible. So this bottom one says the pace of development of digital tech is increasingly rapid, e.g. large language models, but other developments are out there. And so a sense of really needing to keep pace. You know, we're not keeping up if we only tread water with what digital innovation might be possible for us. So that's where we need to go in the future, and thank you very much for your attention.
Thank you.
Good afternoon, everyone. Thank you for that, Jonathan. I'm there now. Thank you. Thank you for that, Jonathan. Hello, everyone. I'm Chris Needham. I've worked on the Made Smarter Innovation Programme since its launch around 5 years ago. As Jonathan mentioned, there are some streams in the programme that are covered elsewhere in the sessions today. Therefore, for this highlight slot, I'm going to focus the spotlight on some of the other strands of the programme. So in a moment, we'll shortly look at the biggest set of investments we've made in collaborative R&D projects. But I'm going to start off by talking about one of the smaller set of investments we've made. Smallest yet perfectly formed, I'm told. So we're going to look at the digital accelerators. What are digital accelerators? So they're a relatively new intervention model. They're partnering together here large multinationals with ambitious, young, agile, bleeding edge technology and typically early stage micro-sized businesses. So David's working with Goliaths to demonstrate technology that tackles an industry challenge and at pace. Real can-do attitude. So very quickly, for those of you not come across the accelerator model, each SME is given a remit and funding to do essentially sprint-style developments to develop a proof of concept, with the most promising of those then selected and given further funding to develop a minimum viable product. Here we have, on the right-hand side, two very small, although I'm pleased to say they've grown since their project a couple of years ago, very small SMEs that were developing tech solutions for huge industry giants. So the first one, top right-hand side, we've got Machine Intelligence, who are working on a challenge that's sponsored by BAE. This project, you can see the guys there looking at digital X-ray images of metallic components with the challenge of providing classifications of the state of those products. The challenge there being that it's very low volume manufacturing, so there are very few test samples with defects to train the system. So it was about X-ray analysis, but also developing AI tools that can be trained with very little data in order to inform that machine learning. Bottom project there, Total Control Pro, have worked on a challenge given to them by Safran Landing Systems. This was a completely different type of project. This was to develop a dynamic scheduling system, which was needed to drive productivity in what would be a very complex and slow routing environment, where small delays can have a big knock-on effect. The solution that was delivered by Total Control Pro in relatively quick time, they developed a rules-based, yet also scale, because it's aerospace, so things need to be rules-based for obvious reasons, yet scalable and adaptable solution. And that was driving in lots of real-time data sets, huge amounts of data sets, and using those to make complex scheduling decisions quicker and clearer. The great thing about these projects is both of these technology providers were new faces to Made Smarter Innovation about 4 years ago. And then through this technology accelerator, and then having delivered successful projects there, they've both gone on to deliver expertise in different areas of the MSI stream. And that's been fantastic to witness that growth. So moving on now to the CR&D, the large CR&D portfolio. So this particular slide here depicts one of the focus funding calls that we had, that we ran. This was on industry-ready robotics and automation. So accelerating ideas from the test bench into production-ready demonstrators. Getting it over the hump, as I describe it, to get it from something that's an idea and a set of principles into production land. On this slide, I'll give you a flavour of some of the brilliant solutions that have been demonstrated in this cohort, and just a whistle-stop tour of a few of them. So top right-hand side of the photos, there we've got Rivelin Robotics, stood in front of one of two robotic kits that they built. And this was a project that spanned from gas turbines through to dentures. I've learned an awful lot about dentures in this role, through to quite small aerospace components. The challenge here is these are additive manufacturing components using metal additive manufacturing. And the challenge especially there is that the build support materials then need to be removed, which is usually either technically prohibitive or expensive or manual or all three. This project uses a tool changer and a multi-head robot arm in conjunction with some visual scanning and also a lot of force sensing to cut, to grind, and to air chisel off in some cases the support structures, all without any human intervention once it's been loaded in the machine. This is fantastic. Much cleaner, much safer, and much more repeatable. Bottom set of photos there is a food production environment. Those of you who've worked in food will understand that that's a very harsh working environment, super cold, super slippery, full of repetitive tasks. This project has combined vision systems and AI picture recognition at tremendous speed, together with an automated weighing platform and a pair of cobots that work in tandem to identify the best size piece of chicken by estimating its weight to pick up and put on the sandwich, or bacon, etc., all at line speed. It's fantastic. It gives repeatability and accuracy that matches, and generally it actually exceeds the ability of the human. Let me just pause there. Neither of these two robotic projects are likely to take jobs away from people. The challenge in both of these industries, although they're different challenges, is they can't get the people. Top right there, one of the partners in that project, Attenborough Dental, they would love to grow their business, but they've got highly trained people chiseling metal off denture builds. What they need is accessible, repeatable, low-cost solutions. There's one. We've built it. Actually, I did nothing. They built it. Food industry. They can't get enough people. While they've got people repetitively putting chicken on sandwiches, they're not building Jonathan's tuna and mackerel and Scottish smoked salmon sandwiches. They're not building the higher product items because they're bogged down building the lower value items. It opens up new areas of opportunities. I'm just picking one more from the list here. I won't go down all of them. Number 3 on the list here, and they're in no particular order of favourite children, but robotic high accuracy polishing of spheres. So imagine, if you will, a research submarine and the dome that would sit on the top, the hemisphere that sit on the top or the front. Those are made from acrylic, typically a couple of inches thick, and they are manually polished by experienced operators. Two small SMEs working together, A3L and HAL Robotics, worked with the manufacturer to develop a robotic system to model, sense, and actually polish acrylic spheres without inducing stressors, which is pretty challenging if you induce stress on a product that goes subsea. HAL Robotics are on the stand outside if you want to go and see some of the work they've done. Fantastic, some of the things that have been built. Another funding call we ran, which was focused on CO2 reduction. Global warming remains obviously a real threat. However, digital innovations and the insights in control and visualization are going to be some of the most critical tools in our toolbox to be more efficient in manufacturing, to be less wasteful, and to drive down CO2 emissions. So on this side here, you'll see some of the projects from a funding call that we ran. The top set of photos there, that is a very small company, Deep Meta, pushing the boundaries of AI. I know we've got some of the Deep Meta colleagues in the audience here today. They're working in conjunction with the steel industry to make sense and at speed of the multitude of data that can be acquired within steel manufacturing. And yes, of course, they use a lot of that data, but there's an awful lot of that data that is currently unused, and they're using that to optimize the parameters for the running conditions and indeed the loading patterns of some of the furnaces. Fantastic to see a small company working with a large steelmaker. The bottom set of photos there, that's another AI deployment. This time is on a much cleaner process, just to give you a range of examples. This is on plastic 3D printing, so filament printing. And this coupled with a high-speed camera. Apologies. This coupled with a couple of high-speed cameras keeps an eye on the process and then can detect using machine learning in real time early stage defects just as they're starting to be created, gives the opportunity to either abort the print, and they've built a robotic solution that automatically ejects and moves on to the next part, or to potentially correct the build as well. So what are some of the things that we're most proud of achieving? I'm bored of that. You must be as well. So here we have an unofficial top 3. Number 1, we've connected in untapped potential within the technology sector. We have a number of early stage technology developers that, prior to our work with them and bringing them into the family, were sat outside of the manufacturing sector. And we've been able to encourage those businesses to come in and work with manufacturing providers. Several were brand new to the sectors, and that's particularly true in emerging technologies, large language models, generative AI, lots of things in the machine learning space as well. We've extended relationships across the technology and manufacturing ecosystem. So lots of large and small manufacturers have continued to work together on different projects post the project that we'd funded. So that's great to see that happening. So we see some of the consortia projects, some of the consortia photos there where we've pulled projects together to knowledge share with each other. An example of that ongoing relationship is Machine Intelligence, who I guess most of you have not heard of because they were about 5 people in a shed a couple of years ago, continue to work with a mighty giant that is BAE Systems. That's fantastic. But perhaps the thing I'm most proud of is that we've demonstrated the power of new digital solutions to drive carbon abatement. As many of you are aware, and you may have seen in some of the earlier sessions today, I'll just dive over here. For those of you who've seen this resource efficiency diagram before, and don't worry if you haven't, but between now and 2035, before lots of great technologies such as carbon capture and hydrogen, etc., really kick in, we've got to drive this change through resource efficiency and energy efficiency, and digital is a great enabler of that, and we've proved that a lot in this challenge. I'm going to skip over the video just in the interest of time. So just a quick recap, different areas of the different streams we've used in the Made Smarter Innovation Programme across the last 5 years. I'm going to just pause there for any quick questions that we've got in the last few minutes. If I can ask my co-presenters, Philippa and John, to step up to the stand. Delighted to take any questions that you may have. Thank you, sir. Just use a microphone for the benefit of those on the call.
Hi, my name's Chris Walker. I run a micro SME in the Midlands. We're in desperate need of assistance with digitalisation and data analysis. Made Smarter isn't available in our area at the current time. Are there any plans to implement it?
I can take that firstly. You said you're in the West Midlands? East Midlands, yeah. So as of the 1st of April, so just a few weeks ago, the Made Smarter Adoption Programme, which is a cousin of the Made Smarter Made Smarter Innovation Programme, that rolls out across the rest of England. It's already in some regions from the 1st of April. So if we catch up afterwards, I'll try and point you in the direction. Okay, thank you. Just 1 minute to go. Any further questions?
Thank you. In terms of your technology partners, do they have to be small, micro SMEs, or do you deal with larger providers as well?
Yeah, so the current programme that we're reporting here, my apologies I didn't say, it actually comes to a close at the end of March. So we've deployed our fundings. But throughout the programme, we've worked with, you see we've got different streams. Most of the streams are open to most organisations of any different size. And then a couple of them are specifically focused on SMEs. But if you take the largest pool of investment, the £60 million of investment that's gone into collaborative R&D, I know that, because I run the stats as well, that 50% of that funding has gone to the smallest of businesses, then another slug on top, about 25%, and nearly 75% of that funding has gone to small, medium enterprises. Yeah, but it is open. It has been open to all. Okay, I think we need to wrap up there. Okay, I need to make it super quick because there's another session on afterwards.
Hi. You said the current program is ending, so what happens next?
You want a quick answer? So, Jonathan, feel free to cut in if you like. There has been a recent spending review, and we are in conversation with government about how that pans out for the next year. There will be something coming. We've just got to wait for that to work through. Thank you for the question. Watch this space, I would say. There is a Made Smarter website, which covers both the Made Smarter Adoption Programme and the Made Smarter Innovation Programme. Periodically check into that. And actually, if you haven't already, sign up to the Manufacturing and Materials newsletter. That will give you information on what is coming next when it comes. Okay. Thank you very much indeed. Thank you for your time. Thank you for your questions. Enjoying the rest of the day. As Jonathan said, there are some sessions on later as well.
Okay. So welcome everyone and anyone joining online as well, actually. We've got a session now on the role of the digital twin. And it's something that Innovate has funded through a number of its programs. We've funded a variety of projects that have either been solely looking at that or utilizing it in some way. And we're going to hear from 3 of those today. So we've got Ruan from HSSMI and Harry from Grey Parrot. They've both been working in this area related to waste management and the use of digital twin concept in that sphere. And then we've got Katrina from Artemis that's going to talk about digital twins and their role in maritime decarbonisation. So we'll go through this. I'll have about 10 minutes each and then hopefully a few minutes at the end for Q&A. All right. Right.
Hi, afternoon all. So thank you for coming in today. So my name is Ruan Karunaratne. I'm a senior technical at HSSMI. So I'll be giving a little bit talk about the project that we have done on the Veolia project. So about myself, I'm a senior technical lead at HSMI, and I've been working over 10 years in the manufacturing and the digital side of things. And in terms of HSMI, we are a consultancy based in London, so we mainly work in manufacturers to scale up their processes and improve their processes and optimize their machineries and equipment. And we've been scaling up some of the startup businesses from prototype into volume manufacturing, either low volume or medium or high volumes, and also improving the overall the production strategies, and then looking towards the circular economy side of it. So how can we all the materials that used within the business, bring it back and reuse it and use it for simply extend the value of those materials. And yeah, so that's who we are. In terms of the projects, the project called PT Full Loop. So the innovation behind this project is bringing all the PT waste plastic that's been collected from the curbside and then bringing into the plant and recycle it and reuse it again for either food grade bottles or non-food grade plastic trays for packaging. It's been, we started the project in 2000, almost like 5 years ago, so but we are coming to end the project in end of the next month, but it will continue for like another 6 months just to hand over some of the work we have done on the digital twin side. Our key project players being Veolia, who's the actual demonstrator of this plant, and we have the Unilever, and who's Unilever and Charpak, who are the end users of this products that Veolia is going to be producing. And they've been also been advising about this manufacturing plant, how it needs to be run, and what sort of tests that need to be run in these. So at the end of the day, they get a quality products for their process. So us, HSMI, we've been supporting on the digital twin side. So effectively, this is a brand new plant, and we need to understand how the plant is being laid out and bringing all the digital assets onto the plant, onto almost like an existing existing layout of this building to make the infrastructure right, so that when the equipment comes in, there's no clashes, no interference with that. So we've been working with the suppliers to get those CAD models in and looking around that. And also the other bigger part is the digital twin. So once the models are in place, and then we run those processes to understand what are the capacities of these machines, so that we have the plant is running effectively, and we can optimize it throughout its processes. And finally, using all those machine data, we run simulation models in the background so that we can continuously optimize the machineries. So in terms of the simple process, we are just showing the standard process that we've been following, which is take the existing machine data and sort the data out, and then put it into our digital twin system, and then get some useful information back. And then that data, either we can directly feed it into the machine to optimize that machine, or we have give that information back to the user who can evaluate and then feed it or change the machine accordingly. As we develop this process, we come to understand the main challenges, because the waste industries, the materials that come in is so vast that you can have when you collect the materials from the curbside, you have the metals, the plastic, the paper, soil, and everything's in there. So we need to understand the composition of these materials, and it's been very challenging because you get all that the materials that will go through that process. So it needs to be assessed each stage, and it has been difficult. But we are getting there slowly, because as we understand, we are slowly moving forward. And then so the other thing that what we get from the partners is the mass balance data. So we understand how much material need to be processed during its journey. So I'll quickly run through a few of the things. So in terms of overall digital twin, when we started building this model a few years back, so we have to understand exactly what is this model, how it will be looked at, how the user is going to be using it at the end. So we have to understand if the system is actually feasible for the operators to use. Because right now what we understanding is when we're handing over the systems that we built into Veolia, so they're going to be struggling to actually use some of the things, because we have to connect into the machine some parts and use those existing data, and also connect into the IT infrastructures. But again, so right now we're just going through the handover process of the tools that we developed. But again, something that you need to think about is initially how the users are going to be using, and the system, is it actually feasible for the organizations? Can the IT infrastructures can be connected to the systems? And also the data streams. Continuously, there's going to be different data systems. The vendors are developing using various kind of the data can be any kind of formats. So you have to adapt to these new things that comes into the market. So bearing those things in mind, so we kind of use the NVIDIA Omniverse for our process, because we can do all the simulation work in the background on different layers. And on top of that, we have the CAD models to interact with. And also we can use it as a single source of truth. So all the data is there in one place, rather than having to go around and look everywhere. Yeah, so moving on to, so ultimately at the end, what we developed was a template model. So what that means is we can build a model into single machine or machine level, or sorry, the line level, or we can assess it for the whole plant. So we build it using templates. So anytime that we want to connect to the individual machines, we don't really need to know exactly what's happening on that machine. So the same thing that we can replicate it along the line, along the line. So we can connect it to the hierarchy, and simply the template model has worked. So again, like, because the Veolia plant has, like, we worked on one particular plant, the processing plant, and the same technology can be applied every other part of the business. So ultimately, it's use the template and plug and play into the machines, and then connect it into the data stream, so you will get everything back. So I think I'm running out of the time. And also we have the AnyLogic simulation model, which is working in the background. All the data is being pushed out in the AnyLogic, and then that's where all the number crunching is happening. And that will be feeding back and using some of the historical data and mass balances data, and also using existing data where the plant has, and then feed it back. And that will give us a very, very useful information. And in parallel to that, while using the Omniverse digital twins software, is that users can interact via the browser. So that's also like a quite good thing, because you don't really need to have a dedicated system built in. So anyone can, across the board, can use this tools. And I guess I'm kind of like running out of time, so thank you very much. So if you have any questions, feel free to ask at the end. So yeah, thank you. And I'll hand over to Reese.
Afternoon, everybody. Looking a little bit thinner in my photo, I see, thankfully. So I'm going to give you an example and a case study of a digital twin in waste. I'm going to set the scene by introducing you to what we do, how we do it, and then I'll come back at the end and talk a bit about what we do with the SSPP to give you a sense. But as Gavin mentioned, really we're about digital twins and data in waste. And around the world, about $100 billion worth of material ends up in landfill every single year, in large part because we have very little idea where it goes or what happens to it. Obviously very bad for the planet, and a massively lost economic opportunity too. So we believe that waste should be treated like any other commodity, like any other resource. And to do that, you need to understand it, to value it. And for that, you need data. So really, we're about digitizing waste, digitizing the waste stream, and trying to get to a place where waste is treated like a resource. And the challenge in our industry is that there's very, very little data out there. It's still very manual. And if you go to a recycling plant or a recycling center, it looks a little bit like this, where any data collection is really gathered by hand. And we only typically cover about 0.1% of the waste that flows through these plants. So it's really a bit of a black hole as to what is actually going through the waste stream, where it ends up, what is being recycled, what's not. And obviously, you can't manage what you can't measure. So what we do is we place these cameras above the conveyor belts in recycling plants, companies like Biffa, Suez, and Veolia. And we use a computer vision model, or AI, to essentially digitize and create a digital twin of all of the waste that's flowing through these conveyors to get a sense of what they actually are, to digitize it. And we provide our clients with a dashboard which shows them data, which we'll come on to as to what's going through their plants, and also integrations. So you can also integrate it to a robot or an optical sorter to start sorting waste automatically based upon the data. So this is what it looks like. We create a digital twin for really every object that we see, and we layer on 7 pieces of inferred data off the back of that. So we can determine the material type, the polymer, the mass, the value, its potential CO2 emissions, whether it's been recycled or landfilled, and even all the way down to the level of the SKU, so what the product is, what the brand is, be it a Coca-Cola bottle or a Pepsi bottle or what have you, and I'll come back to that shortly. We do this today across 89 different classes of waste. We're just expanding this now to about 120, with a lot of depth, obviously, in plastics, but moving into aluminium, wood, and others as well. And so really across a plant, you might have up to 25 different units, depending upon the type of plant. And this would really cover what's coming into a plant. This would cover the sorting lines. It would cover the product line, so we can see how pure the bales are, for instance, when you're recycling PET or PP or HDPE, all the way to the residue line. So you can see like what tangibly is actually being lost to landfill or what's being lost to incineration. That actually quite a large proportion of paper, which should be recycled and should be recovered, is actually ending up here in landfill, as one example. And that's obviously a challenge environmentally, but it's also a challenge for our customers. They are losing money for what they could have reclaimed or what they could have recycled, and they're actually even worse, paying for somebody to take it away and landfilling it. So there's an ROI here for our customers, but there's also an environmental challenge as well. And so for our customers, it really means that they get a real-time view of everything across their plants. They can see the economic value of what they're losing, and they can start to make trade-offs across their plants and management decisions based upon data. They can slow down or speed up their conveyors as they need to. They can rejig robots as they need to, and they can start to automate their plants purely based upon the digital data and the digital twin. And it also means, just briefly, they can also run their plants smartly as well. So you can set up live alerts, for example, which will be triggered if the purity thresholds or the contamination goes above a certain point. And you can start to take action on that immediately. So today, to give you a sense, we're live in 22 different countries in the world, largely Western Europe, North America, parts of APAC. We work with companies like Suez, Veolia, Biffa, and we've got about 140 of these units now live across the world. And just to give you a sense of the scale, last year we collected 40 billion objects of waste recognized through our systems. So you start to get really an amalgamated sense of what's being recycled or not across these countries and across these geographies. Just to wrap up, we're starting in recycling sensors. So today we have a product for waste managers, as you've seen. But increasingly, we're working with packaging companies too. So as we saw, we can recognize packaging all the way to the level of the SKU. So increasingly, as I'll come on to, companies like Coke, Denon, Pepsi are within the remit of what we do. We touch on carbon reduction, carbon emissions, and then also, I think, working with new policy and guiding policy with data too. And I think in the UK, where we have the rollout of extended producer responsibility, for example, we want to see that underpinned by data as to what's really happening in real time in the UK. And just to give you a sense on brands, so being able to recognize the brand and the SKU, we start to get actually a really accurate picture of what's actually being recycled, not just what people say is being recycled. So we can see and we can understand consumer behavior as to what people are throwing away, what's actually being sorted or not when it gets to a recycling center, and then what that means for packaging design, for brands, their own data, and how they might improve that over time. So just already, we've seen just through our data really interesting insights where, for example, the label and the size of the label has a really quite a massive bearing on whether that actually gets recycled or not. And there's I guess, an optimal level where you want to be to get it recycled. So you start to see some really, really interesting insights at scale as to recyclability. And just to kind of round off, we worked with the SSPP a couple of years ago on a project with near infrared. At the time, it looked a little bit like this, quite conceptual, quite complex on paper. But at its heart, it was about how do we go even further? And today, we recognize waste through just RGB cameras, so like you would have at home or just like you would have on your phone. And we're using AI, computer vision, to infer data just using normal cameras. We want to go even further. And so the project we have is very much about how do we integrate near infrared into what we do as well. And so rather than just inferring particular products, we actually get for the first time a genuine, accurate sense as to what the ground truth is for a particular polymer. So we can start to really recognize with AI, with near infrared, all of the waste that's flowing through these plants and to get really granular into PP film, PE, et cetera as well. And today it looks a bit like this. So we have a manufactured unit which sits alongside our AI model. Still in production, still conceptual, but we're hoping to roll this out this year. And really this is about taking what we do to the next level, to recognize all polymers that flow through waste streams in our client sites, and to take our recycling up to the next level. So that's me. I hope it gives you a sense of, thank you, cheers. Hope that gives you a sense of a digital twin in action in waste. Any questions, feel free to ask me through the email afterwards. Thank you.
that's me. So thanks for having me, and thanks for the previous talk, it was amazing. I am, well, Director of Government Programmes. That really means I lead on collaborative R&D at Artemis Technologies. You'll hear more about Artemis in a minute. Really, I'm an engineer. I love modelling and simulation, and that's why digital twins, something I'm passionate about, so hopefully you'll hear more about that in this next 10 minutes. That's pretty much what I'm going to be talking about, what we're doing in Artemis Technologies to decarbonise maritime. We're a spin-off from a race team, so basically an America's Cup race team that spun off to take the technology that had been developed and put that into the wider industry in order to decarbonise maritime. But really at the heart of all the skills and the tools that we brought in there are modelling and simulation, and some of our expertise in that area around simulators and the use of real-time human-in-the-loop simulation is at the heart of everything that we do. This is the technology that we're developing. It's foiling battery electric vessels. You know, we started off with a prototype. You'll see on the next slide. But this boat is about to be launched in Belfast in September this year. So we're bringing this incredible technology that brings together things that you would see in automotive and the aerospace industry and maritime, and combines them into your product. That's taken a lot of technology and a lot of skills as well, and trying to loop them all together to make sense out of it. And at the heart of what we do is this innovation. You know, we started with a prototype, and in the last 3 to 4 years, we've developed variations of that prototype on a platform-based approach. So crew transfer vessels, luxury vessels. We've got the ferry coming, and the reason that we've been able to innovate so quickly is because of our use of digital twin technology and the skills that we have in design and simulation. And I kind of think of this as, I'm happy to say this isn't the first time I've seen this statistic today. So 80% of the environmental impact of your design is built in at the design stage. And I kind of thought this up as a 7 habits of highly effective engineers. And it's basically getting your requirements right to design the right thing, and then think about what is the end of your product? What are you going to do with it when you're done with it? But to design the thing right, the steps that I have in the middle there, those other steps around choosing the right tools, being data-driven, evaluate often and consider your evidence so that you can fail fast. We can do that through digital twins, and that's the heart of what we do with our advanced toolchain. So in Artemis, our toolchain consists of models of various fidelity. So we've got very high fidelity computational fluid dynamics simulations. We need to run those in real time as well. So we're doing a lot of reduced order modeling, and structures have to be modeled as well. So these are models that are very typical in aerospace engineering that we're using in maritime now. But at the other side of that, we have socioeconomic modelling. We need to sell our technology to people who haven't considered buying it before. Electrification's new to them, decarbonization's new, so we have to put ourselves in the position of the user as well. So there's a lot of models of various degrees of fidelity built into our technology. But at the heart of that is the human-in-the-loop simulator. So that's where we take the data that we measure on the water, the flight control system data that we have recorded on our boats, and actually replay that on the simulator to see how it compares with what we'd modelled. And you can see here, the level of detail we've got is that our flight control system is actually embedded into our computational fluid dynamics, so we can run real operations, and the amount of data that we can recover from that, then we validate by test. And that's hopefully what I am potentially stuck. Can you move me on to the next slide? Oh. I went so far. I need to go back one more, I think. Yeah. Hopefully it'll stay there. Validation. So validation is the heart of everything that we do, because you can model anything, but if you haven't got a way of validating it, then your models are really very theoretical. So we do side-by-side testing on our battery electric vessel with an equivalent diesel boat on the water. They're heavily sensored, measured, strain gauged. We record all the data and do side-by-side comparisons, and it's really only through that kind of validation of on-water data Oh, sorry, videos are playing. You can also see our wake reduction's pretty impressive there as well, at speed. So you can see that the foiling boat's the one without the wake. But yeah, you'll probably be familiar with that double V of digital twins. You know, verification and validation is really the key thing there for the models that we do. And that's at the bench test stage for our components, but also on a system level and a whole vessel level as well. And we have partnered through the Digital Twin Centre, which is led by Digital Catapult and funded by InvestNI and the Belfast Regional City Deal as well, in a collaboration with Spirit and Thales to really drive forward the digital twin technology within Belfast and Northern Ireland, and really with the mission of actually trying to, under the leadership of Digital Catapult, roll this out to SMEs, you know, really be a storefront for the UK for how this kind of technology can be delivered. And for us at Artemis, what we care about there as well is gaining new skills to filling in the gaps that we don't already know. So we're pretty comfortable with what models we need to build, but there's a lot of things in digital twin technology that we haven't got right yet. So, you know, I'll not read the list, but we know we build models. We need to know what we're physically representing. We need to know what we sense, what data we're extracting from that. But part of the journey is joining that all up into a live digital twin, where your twin is feeding your model, and it's a circuitous loop. And we don't have those answers yet, and it's that learning that we're hoping to extract from this program. And where do we see the use of digital twins? Well, for us, it's across our whole business. You know, it starts at the design stage, as you've seen, but for us, it carries right the way through sales and operations. So our customers will have telematic data. We'll be monitoring the health of all our technology that's there. So we'll have a live stream of data that we'll be continually developing and improving our processes. So that's part of our journey with digital twins, and I'm happy to take any questions at the end if there's time.
Okay, so I think we've got about 10 minutes left for any questions. I'm looking at you hoping that you've got the answer because I can't remember. I actually, right at the start, forgot to introduce myself because I was too busy opening the session. So I'm Gavin Lewis. I'm an innovation lead on the Smart Sustainable Plastic Packaging Challenge, which is the SSPP that Harry referred to that might have had a few kind of blank stares halfway through that. So and we were focused on funding projects that made plastic packaging and the environment around it more sustainable. And that's why two of these projects, you can guess which two, have been a lot closer to me than one of them. But the ideas are kind of fairly consistent through. So there was a hand up a second ago. Okay, go for it.
I've got a question for Ruan. Is it a set piece of software you use to tailor to each client? And if so, what does the team look like to tailor the product to the client? Like, is it 2 data scientists to build the data model logic, 1 CAD designer, and like a project manager? What's that makeup look like?
Can you hear me? Yeah. So in terms of the models that we build, it's so at the end of the day, like we want to have it as a single source of truth. So the CAD models in the same Omniverse software, and all the data is coming in from everywhere else. So everything will be located in the same place, and any user can be like logged in through web browser to actually access that. And then there will be some access levels if you need to be restricted. But yeah, everything will be in one location, and users can access to that platform. Does that answer your question, or did I miss something?
No, I was picturing more the team that actually builds and tailors the system for a client like Veolia.
Okay. Yeah, so for this particular project, it's tailored to Veolia work that we're doing. But then what we're trying to do is the next step is take the work that we have done and almost like, because it's a template work that we have done, you can use the same template for other businesses. So if I want to take into the manufacturing, you can take that because the incoming streams of data it's kind of it's a data, right? It doesn't really matter. But then like there might be some things that need to be customized in terms of name tags and things like that. But that will be done to like a little bit of customization to that particular customer. But in terms of the overall system and the architecture, it's there for anyone to use really after.
So digital twins obviously quite a big buzzword, and we see a lot of technology providers using the term, all seeming to have quite different maybe definitions of what it actually is and what it involves. In your guys' opinion, is it something that has a strict set of criteria that means you're actually developing a digital twin, or has it become a kind of umbrella term for a lot of just data collection and simulation projects?
Yeah, so personally for me, I think you got to distinguish two things. What is actually a digital twin? So when it comes to a digital twin, people get confused about you see the model that's replicated on the shop floor, but the other important part is that data, and you simulate to understand what's happening. So one is the visualization, and one is like the data side of it. So I think more people tend to see the visual aspect of it, but like everything is done on the simulation, and simulation will represent what's happening on the shop floor, and then also the predicting the future. So I think for me, like what's really valuable is the simulation part that's happening in the background, because visually you can see like, yes, there's a machine issue, but then like to understand what is the issue? Is it are you feeding too much material in and it's not performing to the maximum level? So the data will tell you, but like on this visually, it probably give you like a flag up as a red or some sort of indication.
I've got nothing too much to add, really. I think for us, we don't really use the term, actually, ourselves, internally or with customers. Really, I suppose it's about the value we can bring them and the ROI we can deliver. And I think it's very easy to peg yourself into somebody else's definition, and we see this a lot with AI. So, we've been a computer vision company for, 4 or 5 years now. But what does an AI company really mean these days? Whether it's a large language model, whether it's a computer vision-driven product. But we get categorized in the AI bucket through the value that we deliver. And I guess it's reasonably similar with digital twin here as well. One can get probably quite precious as to the exact definition. But in the sense that you described there, in terms of being able to try and extract some insights and digitize a physical asset that you can then sort of simulate digitally, that our customers find valuable, and that we do, but we don't call it a digital twin as such.
I suppose I would kind of agree with your statement that I've grown up in modelling and simulation in aerospace for a long time, like 30 years, and I've always thought of it as a collection of models. But for us, the thing that drives it beyond a collection of models is really what you extract from that data, like my fellow panelists have said. But also for me, it's the joined up bit. It's having your design evolve from the data that you've captured from on-water operations. For me, is the bit that is digital twin-like, and that's what we aren't doing yet, but we will be doing through this project.
Thank you.
Okay. Any more questions? I think we've run dry. Okay. So, should we wrap the session up earlier? Anyone, do you want to make any more comments before we go on? Or in which case, can we thank our 3 speakers, please, for the session? And thank you very much. I think the next session starts in a few minutes. Okay, cheers.
Good afternoon. Good afternoon, everybody. So you're very welcome to move forward a little bit if you want. It would make it easier for people to sit down as they come in later on. But equally, I know people say this and then everyone stays still and doesn't want to get up. So if people do want to move forwards, they can, but don't feel that you have to. Thank you. So thank you very much for coming along to, firstly, the event, the Materials and Manufacturing Showcase, and choosing to join our discussion on transport infrastructure. This is quite a broad topic. We could go in quite a few different directions. We're quite happy to. We've been chatting around quite a few different things earlier today. And we will have time for questions as well from the audience. So think of your questions. I'll say this a few times because I desperately want some interaction, and we'll be over very early if there are no questions. Just before we do the questions, there's a few topics that we're going to talk about first. And I'll kick those off in a minute, but before that, let's do some introductions. So first of all, I'm Alistair Barnes. I work at Innovate UK. I'm a senior program manager. My main area is on transport innovation, and I lead a program with the Department for Transport, which is looking to decarbonise the UK's heavy goods vehicles. We're looking both at the technologies and the business models that are needed to do that, and trying to sort of understand what the UK needs to do by doing some large scale deployment and testing it with customers and operators, and put it together and learn from that. So Mark, would you like to go next?
Good afternoon, everyone. I'm Mark Lismore. I am Director of Infrastructure Development and Delivery for National Grid's electricity transmission business. My teams do a range of things. I've got teams that carry out analysis of the system and identify what we need to build in order to accommodate new generation, new sources of demand. I've got teams that carry out innovation that is relevant to electricity transmission. And I've also got some teams that are carrying out construction jobs. So infrastructure builds like the London Power Tunnels, which is a 30-kilometre tunnel across South London to put new cables in to support London's demand, or the projects to connect the new Hinkley Power Station, a part of our portfolio of construction projects as well.
Thank you. And Gareth?
Hi, afternoon all. I'm Gareth Evans. I work for Network Rail in our R&D department. Just to give you an idea of the kind of scale and scope of Network Rail's responsibilities, we look after all of the Great British Railways mainline infrastructure for the railway. So that's about 20,000 miles of track. It's tens of thousands of structures, of earthworks, and we also are responsible for managing the 20 largest stations on the network. And if your train ran on time, you got here on time today, that's fantastic, and please come say hello. And if you had any glitches, then I can give you the number of somebody who can help you in the future. In terms of R&D, so my role is kind of across Network Rail, looking for those opportunities to get the best out of the resources we invest into our R&D programs. So in kind of financial terms, that's broadly about £140 million over this current 5-year funding cycle, but we are very active in seeking other partners who have common challenges, so we can kind of share the investment and resource required to solve those challenges to get the best out of the funding we do receive from government and the taxpayer.
Thank you very much. So as a reminder, we will want questions from you. Do think of your questions. I'll come back to that. But first of all, let's just talk amongst ourselves for a minute. So this is a Innovate UK event with people doing innovation. They're talking about innovation, and that's the main focus. But then you two are from established organisations, and we're very conscious that deploying innovation in a live network that people are depending on day in, day out, and they need it to keep functioning, that is difficult. So I'm interested in your personal opinions or your organisation's approach to deploying innovation live.
Okay, and so the electricity transmission system, we would say obviously is the backbone of the electricity network. In England and Wales, we run the physical assets in England and Wales that carry power at high voltage, effectively like the motorways for electricity. It has to operate 24/7, 365, and it's big news if it doesn't. The transmission system in this country has been tremendously reliable over the years. Yes, because of the amazing work people like me do with National Grid, but also because we have a legacy of something that was built in the 60s and 70s that actually was extraordinarily resilient, built with a lot of sort of future capacity in mind, and has enabled the UK to do whatever it's needed to do over the last 40, 50 years. So National Grid's sort of heartbeat, if you like, has always been to keep the lights on. You know, that is fundamentally our job. There's an undercurrent to that, though, which is keep the lights on safely as well. So our assets are both Yes, they have an electrical function carrying power around, but they are also physically present in the community. They cross motorways and railway lines, and we have assets in communities, near communities. So deploying innovation in that environment always carries an element of risk, and we're sort of inherently risk-averse organizations. You know, it's sort of in our DNA to be very, very careful about introducing new things into tried and trusted traditional assets that we know work, that we know operate safely. And therefore, there is always a level of assurance and a level of understanding that we need that is sort of a natural barrier, in a sense, to deploying innovation. And we know that that's got an unhealthy tone to it as well. We can be held back from trying new things because of that overall ethos of keeping the lights on, keeping people safe, making sure our assets are okay to be out there in the community. So we know that's a challenge for our kind of organization, I think, to be innovative, to think in an innovative way, particularly given some of the challenges we've got as an industry, the energy industry. But it is sort of something that kind of sits there as a natural resistance, if you like, that we need to get over and work our way through.
Thank you. And Gareth, same question to you about deploying innovation live and how you do it.
Thanks, Alistair. Well, I think railways also a regulated, safety-critical sector of the economy. So for good reason, we also have some kind of similar checks and balances to Mark's outline there in place to make sure change is carefully understood, scrutinised, and then when we do deploy change into the operational railway, we know that the impact on passengers and freight users is only going to be positive. And that sometimes gives the impression that the railway is not innovative, but it's our 200th birthday this year. And if you look over those 200 years, we generally have made progress, and there has been some great innovation. So, for example, today, the service train that many of you will use to get about contains more instrumentation, checking the condition not only of the rolling stock, but also of the fixed infrastructure. So massive advances in the way we are using kind of digital technology to understand the condition of assets, both moving and fixed. And with Great British Railways, I think that will only get more efficient and effective in terms of how we share that data and understand how the system performs as a whole. Within Network Rail, look, there are some interesting kind of organisational, cultural challenges to the way we deploy innovation. But I'll take a bit of a step back to deploying it safely. One of the kind of key rules within Network Rail is test as much as we can off the operational infrastructure first. So when we've got that kind of list of requirements to make sure something's going to be a safe change to what we do, how much of that can we do in the lab? How much of that can we do at test tracks? It's one of the reasons why in South Wales there's significant investment in the Global Centre for Rail Excellence, because that will provide the even better opportunity to do more testing offline, as you were, to give more confidence about deploying that technology on the railway. But in terms of those ideas that kind of do make it through those stage gates, we know that the keys to success are often having a really engaged, effective sponsor that sees a project all the way through from start to finish. And that's somebody who's got decision-making authority and a budget and can take an idea and scale it up within the business. It's all about having end users engaged through the process, but it still takes time because we're in an organisation that is risk-averse. Nobody wants to be first, even with lots and lots of support to be first. So we've got some of those kind of challenges, but we're developing techniques, I guess, to help work with this vast range of stakeholders to streamline where it's safe to do so, some of those processes and developments.
Okay, thank you. And in that answer, you've talked about regulation, you've talked about safety, you've talked about risk, which are all things I had written down to talk about in a minute. And how, when it comes to risk, I imagine in quite a lot of these cases, you're dealing with a smaller supplier of technology or equipment, and there's probably a bit of a power imbalance. And I wonder how you deal with risk there, how you make sure that it's distributed fairly and it's not the customer that is taking that risk. Any particular thoughts?
I mean, we've got quite a good example of that, and you're right. Whenever you're dealing with, or very often when you're dealing with new technology, it can be a smaller company, particularly of scale compared to the utility itself. And that gives risks from a deployment point of view, from the network point of view, that you are going to be able to service that piece of equipment, that equipment is going to work for 40, 50 years, and that you're going to be able to build enough of them. If actually it's a very good innovation, what you then want to do is deploy it more widely and build lots of them. So the ability to build one versus scale is very important. We've got a very good example of what we call grid enhancing technology. So a lot of our innovation at the moment is around how do we get more out of the existing assets that we've got? How do we move power around so that we can use the existing network as much as possible, move power around, manage costs for consumers? And I think the way we worked our way through that one was working very closely with the organization and actually them being very transparent on their financing, us offering routes to finance that enabled them to build capacity, build capability, build staff, to enable them to sort of grow their business in a way that first enabled them to get that first deployment away, but also enabled them to scale. So I think there is a responsibility in a way on the utilities that do have the access to funds to be able to nurture the innovation along and help the companies build. But always know that the sort of check and balance for the consumer is knowing that ultimately the risk sits with us in the sense of being the network, being the regulated network that can, that has to both justify why we're doing something and the cost that we incur in doing it. And we have to provide that information to our regulator, and they will hold us to account fundamentally on the consumer's behalf.
Thank you. Gareth, anything to add?
Yeah, I think from an our perspective, and particularly in the kind of research innovation space, we want to get the most we can out of the kind of the procurement regulations and what they allow us to do in terms of engaging in a competitive way with innovation and innovators early on, and then be allowed to kind of continue working with the successful organisations that demonstrate proofs of concept, deliver the kind of objectives of Network Rail and the kind of safety, train performance, efficiency targets we've got. So partly I think it's about educating our own procurement teams to innovate in procurement. Sometimes there's a reluctance because I've certainly kind of come across the view that to use the procurement regulations to allow us to support innovators through that scaling process, we need to know up front every I dotted and T crossed exactly what it is we want. And clearly innovation, that's not possible. We need to have that flexibility. And I believe the changes in regulations will allow us to do that and have that more continuous relationship with small, medium enterprises and work with them to scale successful ideas and scale the benefits that the railway sees off the back of that. I think as well, sort of latterly, sort of understanding what organisations like Innovate UK can offer in terms of advice on SMEs to scale and find funding and find capital to support those businesses. Because I know Network Rail works on geological timescales as far as most SMEs will see it. So managing things like cash flow is, I think, can be a bit of a challenge unless we are kind of better aligned with those sort of demands and needs as well. So I guess we've got to kind of move as far as we can in terms of having that kind of entrepreneurial culture and being able to work at the pace that SMEs need to work at. And there are ways, I think, of doing that, particularly with the way the procurement regulations are changing to help us do it.
Okay, let's talk about procurement a little bit more before we go to the audience for some questions. I know that there are, so I found a stat that cement and concrete are 1.5% of UK emissions and almost 10% of manufacturing emissions. So a huge both sort of challenge and opportunity. And we know that there is lots of innovation in this area and different ways of reducing the emissions associated with those materials. But thinking about procurement more generally, and this can be of materials or it could be of sort of hardware that's going into the grid, how how through procurement do you think you can procure the right technology and maybe work together as an industry and a bigger organisation than just yourself in order to help progress in these areas?
Certainly from the energy industry point of view, from the electricity transmission point of view, the supply chain is a sort of well-known problem, whether that is supply of materials, transformers, overhead lines, bits of substation equipment that we use, or supply chain of skills and labour, and the companies that can actually put these things together as construction jobs are both oversubscribed, whether that's globally or nationally. And that's been a conversation we've been having with our regulator. And it is about taking a little bit more risk, in this case on the consumer's behalf, to actually buy ahead of need. That's been one way we effectively have controlled costs in the past, that you only buy what you need, you only incrementally add to the network to connect new customers, and that then covers the consumer's risk. Right now, the biggest risk for consumers is not being able to build the things that enable them to get to new sources of power or to get new demand on the network, which is providing some sort of socio-economic benefit. You know, new data centers, steelworks electrifying, new battery, car battery manufacturing facilities, all of which offer jobs, but all of which need network capacity and need assets building for that. So certainly that kind of takes some risk in procuring ahead, because the risk of not having things is more than the risk of buying something you don't need. And then, and the
so
other
just to interrupt you quickly, would you consider that procuring based on strategy and not procuring based on a spreadsheet in finances?
Yes, although you still have to use a spreadsheet to get to the strategy of, you still need some quantification of how many you think you need. But I think it's buying on probabilities and buying on sort of a little bit of confidence curve of how wrong would I need to be rather than am I specifically right, which is about taking a little bit more risk in procurement. But actually it also leads you down a path of more standardization. So in order to buy ahead, you need to sort of take some of your decision making out of individual designs and buy many of the same thing, which is then more deployable in order to manage that risk that you've bought the wrong thing, because it's very unlikely you've bought the wrong thing if you can deploy it anywhere on your network to meet any need.
Okay, thank you. Gareth, is there anything you wanted to say on procurement? Otherwise we'll talk about electrification.
I guess I can mention a bit about what Network Rail is doing on steel, concrete, stone as some of our biggest carbon sinks in our assets. We are part of the infrastructure client group across government, and that is kind of our chosen route to working with all of the other large, national purchasers of these sort of materials to pull together on what are the kind of range of options in front of us to decarbonise those key assets, but also how do we pull together on what's I believe the right term is advanced market commitment. So as a group of kind of government purchasers, what is the demand going to be for those materials in future, and how does that then drive innovation into that part of the supply chain, knowing that there's a much bigger market than what Network Rail can offer by itself there to the value chain. So that's the kind of key thing we're working on at the moment is across government, that advanced market commitment, and playing our part in helping define that to then drive the change.
Okay, thank you very much. I'm now going to gift my microphone to the audience via one of my colleagues. I'm hoping there are some questions. I can see a hand at the back. And can we have a name and maybe an organisation or just how you fit in before your question, please?
Hi, my name is Aidan from a company called Expert Rule. I'm not a politician, but some of the things you've just talked about reminded me of a post that I was sent a couple of days ago about the National Procurement Policy Statement. Are you guys aware of that? Where it's directly making government entities and organisations to work with responsible for having a net spend with SMEs, which is really interesting. And it got released, I think, 2 days ago. I'm not a politician, as I said, but listening to you both, it feels like any legacy large organisation, there's a cultural challenge with a strategic challenge with an execution challenge. if we are an SME and we genuinely believe we could add value to what you guys do in complex processes and all those sorts of things, I'm going to ask a really tough question, sorry. What you've already talked about, sort of buying cycles and procurement cycles can be lengthy. The main reason why we have recently tried to stay away from working with government entities is because exactly that. It's very challenging to actually win the deal, particularly in technology when you've got the super beasts out there at the moment, you know, with all the hype doing what they're doing. Are you able to give me any sort of clarity, sorry for asking a really specific and direct question, but around, you know, we genuinely believe, hence why I'm standing here, that we could help you both. You know, are there opportunities, genuine opportunities, if it fits and really solving complex problems that you would go, yeah, absolutely, we would look at that, and cycles, buying cycles aren't going to be 18 months, shall we say? Sorry, lengthy question, but I was just trying to...
I will try. What can I say to that? When we buy a new substation or a new overhead line or whatever it is, generally what we're buying is a kind of tier 1 contract. So we don't buy everything as part of that contract. And we know a big part of actually some of the investment that we undertake, it's not necessarily welcome in local communities. I happen to think transmission equipment is beautiful, but I think I'm a relatively rare individual that likes the look of a transmission tower. I kind of accept that. But one of the things we can take to communities clearly when we are carrying out big investments is the opportunities it gives for the supply chain much wider. Now clearly that isn't going to be procured through some grand national grids, a rebirth system and thousands of people bidding in. But it can definitely be part of the supply chain that works down through the tiers of contractors that are employed to deliver it. You know, any one of these jobs, we may contract with Balfour Beatty or Murphy or whoever, but there is a very long list of organisations that have to come together to build any of this infrastructure. And so I think the opportunities, albeit it's very important to National Grid to know that and to be able to understand where it's making that contribution, but it might not be the direct purchaser of those things, and therefore understanding where the opportunities are and that sort of cascade of supply chain, I think is probably where those opportunities sit, if that makes sense. Is that an answer to the question, or?
Yes, stay away from large contract going at an easier level for an SME on a more local level.
Yeah, because generally we're trying to buy the big thing, but there are many sort of components to that, and there's huge opportunity in those components.
Yeah, I think from a rail perspective, it's a similar scenario. We're working with similar tier 1s to deliver our core renewals programs. I think what I will say is within the rail sector, there is definitely a really strong push to be more innovative in terms of the way we work with SMEs, find the opportunities and connect those organisations together so we can leverage the benefits. So, yeah, please don't stop knocking on the door. There are more and more places where we can connect you up with people and hopefully have the right kind of conversations.
Yeah, if I just come again, it's slightly remiss of me to say, in the innovation space, any funding we receive, consumer funding, effectively through the regulator, there is an expectation that we use SMEs as part of innovation in that. So it is actually codified into the way we do innovation to engage directly with SMEs and bring SMEs into that process. So any of the kind of innovation projects that we do, we would have that more direct relationship with SMEs as part of that.
Hi, sorry, Mark Jolly, Professor of Sustainable Materials and Manufacturing at Cranfield University. So you've talked about the cement and the steel, but if the whole of the infrastructure is going to go to electrification, so this is not just, it's everything, it's manufacturing, it's the whole lot. What is the requirement? What is the, I mean, and rail is the same. They're going to move to sort of more electrification and presumably cleaner steel and cleaner concrete or cement. Are you doing the materials modelling requirement for the next 10 or 15 or 20 years to show what is going to be required for that massive increase in infrastructure build? And the associated additional CO2 that will then hit the manufacturing and materials sector, because it's going to be massive. I mean, it's just like a rebound effect. Before we go to full electrification, we're going to have more CO2. Have you done any modelling of that requirement of materials? Because if you haven't, is that a gap that needs to be filled?
So a very candid response is, it would be lovely if we knew what it was we had to build in order to enable much more of that sophisticated modelling. So I'll be honest, I don't think we have in any detail, and part of that challenge is actually pinning down what we need to build. The energy industry at the moment has been a bit of a gold rush of, with a huge push to decarbonise the generation side as distinct from the demand side. Huge focus on the generation side. And a very, very open market. You know, anybody who applies for a connection to the grid, we are duty bound to provide an offer to connect to the grid. And that has led to a gold rush of, I'll be slightly pejorative, anybody with a field or an interest in a bit of land could increase the value of that field by adding a transmission connection agreement to it, all the way through to people who absolutely are dead serious, have a project on the go. And actually, we can't discriminate between those things at the moment. And that's unhealthy because it's stifling the projects that really should be going and have the opportunity to go. So the whole industry is about to go through a reform of the connection process that should better crystallise what it is we need to build. But at the moment, we're in a position of being sort of 4 or 5 times oversubscribed on the amount of generation that we'll kind of ever need to build out to 2050 even, let alone for sort of shorter term 2035 or 2030 goals. So it's actually quite a real challenge for our industry at the moment is really nailing down what it is we have to build, and this year is quite a critical year for that because we feel that pain as well. Because absolutely. Don't disagree, and that is all part of the challenge, particularly during 2025, of trying to reform the way the energy industry works. Because 5-6 years ago, I think the worry was we weren't going to get enough people who wanted to build low carbon generation. The worry now is we're massively oversubscribed, so we've got to sort that out to pin down the plans and really know what we've got to build. That should enable that kind of materials modelling, procurement modelling much better than we can do right now.
Yeah, I guess from a rail point of view, a couple of points. We have got some pretty good models of our strategic renewals plans and maintenance plans for our fixed assets. And there is a project underway now getting us ready for our control period 8, which starts in 2029. So the business planning for that starts at the end of this year to improve our sort of materials demand and carbon demand, if you like, modelling. But that doesn't include the major enhancements works that take place around the country, like the Trans-Pennine Route upgrade or Midlands Rail Hub, that kind of thing. But they are, I believe they're covered by sort of legislation and regulations. Because of the scale of those projects, they have to do their kind of own carbon and materials accounting anyway, and innovation in that space to show they are hitting some fairly tight targets in terms of embodied carbon in the finished product. A gap that I was talking to Mark about before we started this was we're just starting to get to grips with the fact we need some energy modelling for the railway system. It's part of the refreshed rail technical strategy. But I think there's so many potential options for how we would decarbonise traction. There's a lot of discussion at the moment about, well, how do you nail that, pin down some of those and finalise some of those options so that the cost benefit and the carbon benefit analysis is kind of agreed as a sector for where we put electrification schemes in or whether we look for other modes of low carbon traction for the railway system. And I guess finally, last point, we are working with DFT to look at kind of cross-modal research challenges, and that very point, I think, about materials requirements and carbon impact, therefore, of the future of the transport system is in scope at the moment in those kind of discussions. So hopefully we'll get a bit more joined up between sort of road, rail, air, and maritime on that front.
My question's for Mark. Mark, I'm one of those people in the community that's not quite such a fan of the infrastructure that you're a big fan of. Just an observation and a question, really. I've worked with Gareth's colleagues on a step change in infrastructure. So I've worked on a composites bridge, Gareth, which you're putting in, which is effectively making a step change in your ability to put in infrastructure quickly without shutting down the, some of the railway lines. What I don't see from National Grid is this same investment in innovation. So you're underway with the Great Grid Upgrade, and effectively what you're doing is adding more of what we put in 60 years ago. So my question is, what is National Grid doing in terms of that step change? How are you future-proofing our grid for the next 60, 100 years? And why are we not investing in an offshore grid, given that the majority of your future connections and a lot of the grid connections you're talking about are either offshore or in the north of Scotland?
Okay, thanks for the question. Picking a few of those things off, much of the infrastructure might look the same. What's going on in that infrastructure is very different from what went on it in the 60s and 70s. The capacity of those lines is way higher than what would have gone on before. There are some fundamental physics issues about things like cables, underground cables, which take away the visual impact, but add some significant costs in terms of other elements of physics that you've got to manage on the network. So still the most economic way of moving power around is an overhead line. We have new tower designs on our new Hinkley connection. They themselves have some of those challenges. And also a key part of our innovation, I mentioned grid enhancing technology. So traditional risk-averse utilities rated lines at a certain level for kind of the worst condition. Putting new innovation on existing lines allows us to sort of monitor real-world conditions, real-world weather conditions, that actually allows us to get more power down those lines and save money for consumers, because ultimately you can move more and not have to constrain it off. On the offshore point, there is quite a lot of offshore infrastructure being built. One of my colleagues' jobs is the installation of quite a number of offshore links and cables. They have their advantages and their disadvantages too. So they will move bulk power a long way. But if you build a cable from Aberdeen to Kent, as an example, that will move power from Aberdeen to Kent. That will happily move a lot of power or from offshore in Scotland to the southeast. That will successfully meet that criteria. There are other reasons, though, to have infrastructure onshore, as in it's where people live, it's where factories get built, it's where data centers want to build. So by comparison, an onshore line will not just move the power, but it will also provide opportunities to tap into that and connect electrified transport or decarbonized heat or new factories and things on. So I think the development of a grid that has the right balance of onshore and offshore for some bulk power movement, and particularly obviously where you're moving it from offshore wind, but the right balance of onshore, because if all we focus on is just trying to move the power from north to south, we miss the opportunities that the grid built in the 60s and 70s has given us, which is it had that capacity that enabled people to build houses and factories and businesses without it being a constraint. We're in a position right now where it is going to be a constraint in certain areas, and we need to make sure the onshore grid is enhanced enough to enable societal change and build as well.
So we're about 10 minutes left. There's a question in the centre aisle. Sorry to make you walk around. It's okay. It's a question in the centre aisle. Thank you.
Hi, it's Simon Christopher from the University of Liverpool. So I'm going to ask two questions. I'm going to be a bit cheeky, I'm afraid. So firstly, what's the best way for academia to engage with you for relatively low TRL concepts and ideas, given your risk-averse approach to new technologies? And secondly, where do you see digital modules and digital twins fitting into your validation regime for new ideas and projects?
Yeah, okay. Thanks for the question. In terms of academia, we have a very close relationship with the UCRIN organisation, which is now a group of 19, I think at the last count, universities focused on various aspects of railway research. So led by Huddersfield for rolling stock, for Birmingham for sort of digital and a growing range of aspects, and then Southampton for infrastructure. So we engage with them on a regular basis. We have a kind of active PhD program with the Ukraine universities. We don't have to be a member of Ukraine, but I think that's our kind of preferred route to gaining access to a wide range of research capability. I think one thing we want to do with Ukraine is be better at collaborating in terms of accessing the resource and the skills and the future railway engineers than we maybe have been in recent years, where it's been a bit more transactional arrangement and sort of a relationship between us. But no, we're very open to and active in that space. And actually, some of our best value returns from our R&D budget have been on core bits of research that have challenged our sort of the current wisdom in our engineering standards and unlocked huge cost avoidance and cost savings, actually. So one being electrification, where working with universities, we've come up with a number of changes to standards that mean we've potentially saved 200, 300 million pounds on electrification schemes over the next 10 years. So that's the kind of example I like to cite to colleagues inside Network Rail and the universities that we work with to see where are those other sort of nuggets we can come up with. So what was the second part of your question? Digital twins, yeah, I think they're a key part of our kind of future assurance and validation regime. Again, GCRE, I'll mention them again. Part of their ambition is to build a digital twin of their infrastructure. So they're even thinking about how they can kind of reduce the costs of using their facility to validate the suitability of certain innovations on the railway sector. And there's lots of other kind of work going on. We are slowly building more sophisticated versions of the entire network where we can not only overlay the position of assets accurately and the condition of those assets from all the data that's collected day in, day out, but also overlay some of the operational parameters on the railway and start to connect to that kind of system approach together. So looking at the effective asset degradation on the day-to-day operation of the timetable.
I think from our perspective, virtually all of our innovation, we have about a budget of about £100 million that we've submitted to the regulator for our upcoming price control period starting in 2026. Virtually all of that will be either internal cost or with academia or SMEs. So we have a range of innovation focus areas, from enhancing the grid through construction materials, basically focused on the challenges that we've got as a business, as an industry going forward. So we do have those direct relationships with academia there. Very quickly on digital twin stuff, I guess just to add, some of our innovation is focused on things like climate resilience. We have existing assets in places that didn't used to flood and now are likely to flood, or are likely to experience different environmental conditions from what they were originally designed for and envisaged for. So trying to use predictive analysis, digital analysis in order to manage those assets in a different way is one of a number of different innovation programs we've got that try and use that. The other aspect that I'm particularly interested in, given the construction side, is kind of predictive project management and try, because we will be under such focus for delivery on time and delivery to cost of our capital programs, the more intelligence we can put into how we manage those projects using better data and AI, that's a really key aspect for us as well. I spoke to one of my team, I said I wanted Moneyball for construction, which if anybody's seen the film with Brad Pitt, it's a very good film, I recommend it. He hadn't, so he's gone off to watch it so that he understands what I'm talking about. So.
And just before we go to our final question, well, probably our final question, I want to give the Innovate UK angle here as well, particularly on the topic about collaboration and academia. So, of course, there is the Catapult Centres that Innovate UK works closely with. Particularly relevant are the Connected Places Catapult and the Energy Systems Catapult, and they will both have an interest in that sort of maybe valley between academia and business. And then, of course, there are collaborative funded projects, but also relationships that can be made through Innovate UK Business Connect. Whether or not that leads to a collaborative project, maybe it just leads to a collaboration and a new relationship, a new opportunity. So if we could go over to the front here. I think you had a question? If it's gone, you don't need to, but... I'm conscious you don't have the microphone and our online audience might not hear you, so just...
Right. Well, it was actually about climate resilience, which Mark sort of referenced in terms of what the impact is on your infrastructure if, for example, power lines come down, and then what might then happen, say, for example, to the rail network as well. So maybe the question could be put as well to the rail network in terms of what planning are you looking at in terms of your infrastructure, in terms of climate resilience. We've all been there. When issues have happened, and presumably they'll be more frequent in the future, and they'll be interconnected. So power lines go down, it impacts a rail network. That might impact a pumping station if there's flooding. So we all know that's coming. And what are your sort of plans moving forwards? And some of that's obviously digital twinning and elicitation tools. Thank you.
Yeah, thank you. From a railway perspective, we've embarked on some research in our last control period cycle looking at vulnerability and criticality mapping of railway assets, and we're now looking to roll that out more widely in terms of the way our routes and regions use that methodology to look at their risk areas and then build the investment plans or make the case for investment or in the way we manage that risk into the future. I think your point about joining up the dots, though, with what happens if we lose power to a pumping station that causes the railway to flood, I need to go away and ask a few questions about that, because I don't know how deep we've taken that analysis into the sort of the secondary and sort of tertiary impacts that could affect the railway in that way. So yeah, I don't know if there's something going on in terms of critical national infrastructure and a broader piece of work. It's a good point.
For electricity, for transmission assets, electrical assets, the three things are water, water being in places it didn't used to be, or drought and subsidence, so the kind of physical impact on the assets. The electrical impact on the assets is really like heat and wind. Assets are rated based on, the heat they generate, and therefore limited by that. And if they're then operating in warmer conditions, that is likely to sort of derate the assets potentially. So we've got to understand how that interacts with the assets. And overhead lines particularly, the rating of those lines is a combination of how warm it is and how windy it is. So as those change from anything which is what the basis for the rating was originally, and whatever the maths is in some arcane climate study in the 50s that kind of defined what those ratings were, as that changes, and that could go either way. That could enable us to put more power down, the more it could cause derating. So it's important for us to understand all aspects of that in terms of how it changes, what your assumptions are for running the network.
Okay, and we better wrap up there or we'll get in trouble for making the next session late. So thank you very much to the panelists, and thank you for your audience and your questions.
Is that working? Good afternoon, everyone. So I think this is the last session of the day, so hopefully we get a few more people, but I know it's been a long day, so thank you so much for staying with us. Just before we talk about digital factories, I'm just going to do a bit of a plug for the awards night that we've got this evening. So we are celebrating the Women Innovators in the Foundation Industries awards this evening. Really, really important awards, and I'd encourage as many of you to stay if you can, just to really shine a spotlight on those role models who are really pioneering kind of changes within quite traditional industries. So there will be a drinks reception, which will start after this last session, and the evening will finish about 7:30. So hopefully as many of you can stay as possible, and you might have to listen to me because I'm going to be hosting those awards. So this session is very much following the theme of Made Smarter Innovation. So for those of you who heard a bit about Made Smarter Innovation, we've got two fantastic people who have led some of the activity for the digital factories area of Made Smarter Innovation. And they're going to talk about some of the great work that they've done within their centres. The way that we're going to do this session is we've got a small presentation from each of the speakers, and then we're going to open up the floor to questions. And I would encourage you to think about some questions that very much look into the future around where do we go around digital factories. And yeah, I would encourage you to write some questions down, so please help me, because I don't want to be just sat here thinking about questions and asking the questions we've got in advance. So my name is Philippa Glover. I should have introduced myself beforehand, and Made Smarter is very close to my heart because I've been involved in Made Smarter pretty much since the start. So back in 2019, I joined the Made Smarter Innovation Advisory Board, and at that time I was the Managing Director of an SME working, developing robotic solutions for the manufacturing sector. I don't actually work for HSMI, I wear multiple hats, so I am the Director of something called the Foundation Industry Sustainability Consortium, which is working to decarbonise and help the foundation industries innovate and grow, and also work with SME businesses and technology businesses in the UK to really help them kind of scale up and grow. And because I've been involved in Made Smarter Innovation from the start, I understand the importance of these hubs and what do they mean to the community, and how do they really help accelerate some of the changes that we need to see, particularly in our SME base. So hopefully that's something that these guys will touch on, and I know Niels will share some of that work that he's done specifically from a robot side. So I will hand you over to Professor Svetan Ratchev, if I pronounce that correctly, who wears lots of different hats, but is here as the director of the Institute for Advanced Manufacturing in University of Nottingham, and he's going to talk a bit more about the work that they've done as part of the Digital Factories work.
Thank you, Philippa. Can I use this one? I can use this one. So what I'm going to talk about is the Made Smarter Center for Connected Morphing Factories. It is an activity which I lead, and we have a joint approach between three universities of University of Nottingham, University of Cambridge, and University of Sheffield, including the AMRC in Sheffield. So what we're trying to do here is really focus on how we can develop the infrastructure for the future, which is based, in our case, we developed this vision for future factories which are hyper-connected, and also they're made of these self-organizing coalitions of manufacturing resources. And with that, we're trying to develop this manufacturing infrastructure blueprint, which can allow us to configure facilities that are easy to repurpose, reconfigure, scale up, scale down, relocate, or redeploy. And the challenges, we face some of these challenges with COVID, how we can rapidly scale up and then perhaps scale down when the demand is reducing, but still manufacture in a cost-effective and productive way. And also currently we have a significant challenge with defense capability and how we can respond to particular challenges which the defense industry is facing. So in order to deliver this environment, we have focused on 3 different kind of challenges. One is in-process monitoring and control, which is led by University of Sheffield. The factory architecture, semantics, and overall control environment, which is delivered by University of Nottingham. And also looking at the digital infrastructure, sensing, and the industrial Internet of Things, the kind of the connectivity behind the digital factories, which is led by IFM at Cambridge. And with this, we're trying to develop this capability, which is provides the future factories with agility. It's also level of autonomy. We're also looking at multifunctional, multi-product environments where we can most efficiently utilize capabilities of different resources, and also building resilience and sustainability in the environment. So one example of that is, actually in this case here, we have the definition of different research topics, which are better defined here in terms of research themes, but also linking this to specific application studies. So one of the advantages of the Made Smarter program is that it allowed us to link basic research to applied research. And that's quite unique and very powerful in terms of vehicle to deliver faster applications to industry. So in this case, we developed a number of application studies in terms of rapidly configurable machining processes, production integrated 3D printing, which is led by Cambridge. The first one is at Sheffield, AMRC. And then the third one is autonomous assembly of aerostructures, which is the facility at Nottingham. And then we have a 4th application study, which links everything together into hyper-connected morphing factory cloud. And in order to really engage, we have another layer here, the strand 3, which is more focused on networking and the wider engagement in terms of dissemination, industrial pilots and validation, local industry workshops and events, and engagement with students. We had a lot of school children coming to our facilities to really promote how future manufacturing is going to look like. So one of the examples of this is our facility in Nottingham, which we call the Omni Factory. And the idea here is to break with traditional approaches to factory automation and integration and develop a new connected, agile manufacturing ecosystem that can deliver a number of new facets. The first one is cost-effective manufacture of complex products, usually in low volumes. And this is the most challenging part of manufacturing because it's very expensive, and making it cost-effective is one of the main challenges that we're trying to address. Then the other big challenge here is how we can rapidly respond to demand and volume fluctuations. How quickly can we ramp up production and do it again cost-effectively and with high level of productivity? We also need to be better in how we manage design changes, mix and different scheduling priorities at each stage of the manufacturing cycle, and how adapt our manufacturing environment is to cope with changes, particularly late design changes. We also try to dramatically reduce time to market and support rapid production scale-up. And also we're looking at what future manufacturing is going to look like in terms of manufacturing as a service and how that can be delivered. So what are the key underlying technologies and developments on the research side? So we look at full integration of digital and physical infrastructure, then ability to completely collect data using industrial edge technologies, and then leverage that data into advanced decision-making with integrated data analytics and AI. And also we have another form here of really how we capture manufacturing knowledge and how we can package it. And we define something that we call the Omni apps. This is like iPhone apps, but actually capturing manufacturing knowledge and then being able to monetize and reuse that knowledge in different environments, different devices, different resources. And we developed this marketplace, which is still a test environment, but is progressing rapidly to a product. So in order to achieve that integration, we also need to link different levels, plant level, system level, device level, to allow us to start with product requirements and then go through different bills of materials, bills of equipment, and bills of processes, and then deliver both a digital twin environment of the manufacturing system, validate the new design or the new configuration of the system, and then implement it into the physical environment. And in order to do that, we need different types of integrated solutions, starting from product design, looking at the product lifecycle management, planning and simulation, delivering manufacturing operations, and then at the device level, being able to capture performance in order to optimize and improve performance, and also all different aspects of factory automation. In our case, we integrated this using a set of different Siemens products, but the approach is not Siemens specific. It's agnostic and can be implemented with different software tools. In this case, we specifically selected Siemens, and you can see on that side, it's all Siemens products, with the exception of CATIA at the top, because a lot of our industrial partners, which are mostly from aerospace, use Siemens as an industrial environment for their systems in production. So what that allows us to do is integrate the whole product lifecycle or facility lifecycle in this case, starting with product introduction and product requirements which are processed. That leads to initial system design, which then is guided by different levels of discrete event simulation to define the type of system which will be most appropriate for the type of products and volumes that we're dealing with. And then you have a set of different elements of generating OLP programs for the robots, control system synthesis using PLC code generator, and also generating automatically work instructions. Once these are completed, then we go to virtual commissioning of the system using a digital twin of the environment. And once that is completed, we move to the system deployment in the physical environment. So one example of that is this project, which was funded by the ATI, and it was led by GKN. And the idea here was to develop low-cost fixturing solutions that will allow us to automatically configure different fixturing solutions for a variety of different products to be assembled in the same environment. So in this case, we use robotics to first assemble the fixture, and you can see the physical system there implemented. And once the fixture is assembled, then we can assemble different products. In this case, there is a rudder, and there is also a winglet of A350. So I think I have a small video that illustrates the actual digital model of the environment. The first stage was assembly of the fixturing environment on an AGV. Then the AGV is manually operated to the next stage, the next cell here for the actual assembly process. The fixture is positioned accurately. Actually, is not positioned accurately, but we reconfigure the whole environment using metrology. So we have an accurate understanding between the robot and the fixturing environment. And then that allows us to assemble the product. And in this case, you can see a set of drilling, positioning, and fastening operations which are completed on the product. So what this allows us to do is integrate a variety of different elements, from robotics to some manually operated AGVs to a variety of different metrology solutions that allows us to deliver that. I think this is going now into a cycle, so let's move to the next one. So I can conclude with this, that what we achieved within the Made Smarter Center for Connected Factories is in many ways a blueprint for future manufacturing infrastructure, which allows this, or is supported by a fully connected semantic model-based enterprise approach. It allows us to rapidly deploy and scale up production facilities. It integrates metrology-enabled inspection, variation awareness, and low tooling assembly, which drives the cost down and makes complex assembly operations for low-volume products cost-effective, which is critically important. And also it allows new levels of system agility, of responsiveness, and much better asset utilization. And if you want to find more information, you can look at the connectedfactories.org or omnifactory.com websites. And I'll finish with this, just as a small introduction to what the center is being delivering for the last 3 years.
Is it still working? Hello? Right. Sorry, my voice is a little bit rough. It's just a little bit of a cold. So good afternoon, good evening. Thanks for staying for this extended session. My name is Niels Lohse, work at Birmingham University, and I'll be talking about what we've been doing in another Made Smarter Center, which is looking at smart collaborative robotics, which in a way fits quite nicely to what Svetlana Rachev has been just talking about, who is looking more at the factory level, whereas we're looking at more kind of agile assets within kind of local processes using robotics together with people, right? So a little bit of kind of context. So we started with the mission is unlocking, if you like, growth and productivity through collaboration. So what we're looking at is saying, how can we merge together the skills of people with the capabilities of robots, particularly in spaces where perhaps traditional automation isn't quite economic yet, and maybe people perhaps could be supported and become more efficient actually within those environments. And we started with a set of challenges, so research kind of responding to that, and research innovation responding to those challenges. One of them, I think it's the elephant in the room, was most of you who have worked with automation systems before will probably recognize that they're always dedicated and inflexible and designed for purpose, which is good engineering, but makes it very difficult to then actually respond to changes, right? So we were kind of saying, well, can we actually challenge that somehow, right? And saying, can we actually create systems that are easier to change over to other things? Of course, there's also an acceptance barrier, so people now having to work with some kind of robotic systems, share spaces and so forth. So how would that actually be accepted by operatives on the shop floor? How would that actually affect their behavior and so forth? So we felt that it was necessary actually to do some work actually to understand actually what the implications would be for people on the shop floor. We also recognize that there's a high barrier or level of entry, which but has come down significantly actually with the introduction of more easily programmable robots. But nevertheless, there's often a high level of specialization of skill requirements. And again, the challenge was to say, how can we reduce that requirement so that actually someone who comes maybe with more operational knowledge or technical knowledge can actually use those robots to actually support them in their jobs without having to have a PhD degree, in mathematics or robotics. Secondly, the second to last point is looking at capability limitations. So we also recognize that robotic systems are finding it typically quite difficult to work with in unstructured or semi-structured environments. So they often require repetitive environments. So this is something that, again, would actually help us to make them more adaptive so that they can kind of cope with new and emerging situations. And then finally, of course, it needs to be affordable. Right? So we can't kind of create singing and dancing solutions that will set you back a huge amount of money and will not be efficient. Right. So again, most of you are hopefully familiar with this kind of approaches. So the opening doors for collaborative robotics is that there was an ISO standard that was introduced now quite a number of years ago. In fact, there's a new version of this coming out, I think, fairly soon. I think they've been threatening it for the beginning of the year and has been postponed. But anyway, what that actually allows us is actually to create systems where robots don't need to be physically separated actually from people, either because they have some kind of barriers, light gates, sensors that actually monitor their decision, or they're actually designed in a way that what is called inherently safe, but what it means is essentially that they won't hurt you very much. Right? It still means that you have to do risk assessment, right? Very important. So if you stick a sharp instrument at something that moves relatively slowly, it can still be quite painful and dangerous, right? So we, huh? Right, indeed. So we don't want that, but right, but the interesting thing is that actually opens some really interesting opportunities on the shop floor, actually reorganizing things, because you don't need as much space. You don't need to actually have all of this kind of separated areas. And so coexistence is something that is probably relatively widely accepted now, right? Where people say, actually, I can have a robot tending a machine, and it actually shares a space with a person, right? So that's quite good because I don't have to reorganize all my shop floor. So that opens up lots of opportunities as well for the especially smaller organizations actually working in this area. Now, what we did from a research perspective, we're looking at those challenges. So we have two elements within the project that we looked at. One is what are the next challenges in terms of research? And then the second part was, how do we do translational projects that actually adopt some of those technologies and actually show how they can solve existing challenges within manufacturing? So in my presentation, I'll give you a little bit of a flavor of the research and then a couple of the case studies that we used actually as part of the proposal. So we had 4 topics for the research to actually address those challenges that are highlighted in the beginning. So the first one is looking at how do people actually interact more effectively, if you like, more naturally with robotic systems, right? Because we said we want collaborative robots. I will challenge that towards the end of the speech. But we're saying that they actually want to share spaces, maybe actually share tasks, share solutions, and so forth. So what is the challenge here? And one of the things that we looked at here, so a couple of examples, the biggest challenge is making sense of what the person is actually doing. Right? And making that accessible to robots so that the robot can actually then react in whatever designed way it's supposed to react to what that person is doing. Right? And so that requires some kind of sensorization of the space to actually understand where that person is. Right? Possibly you want to even go further, and there's some suggestions that support actually if I understand whether that person feels threatened or they feel actually uncomfortable with the situation, then the robot might want to change its behavior, right, in order to accommodate that. Maybe move a little bit slower. We actually did a piece of work where actually the robot just said, I'm sorry, it seems that you're uncomfortable. And then people are actually more comfortable with that, right? So it's interesting, right, because it recognized, look, you're uncomfortable, and people react to that positively. So there's a whole bunch of work, and we see a number of projects actually looking at digitizing human, looking at digitizing emotion. Lots of challenges, both in terms of the sensing, but there's also lots of challenges around the data side, right? Because we are suddenly now kind of going and saying, we have some kind of digital observation system that kind of makes sense of what you're doing, right? And then we have GDPR, right? And then it becomes tricky, right? So there are lots of interesting ethical questions, not just technology questions that need to be answered in that space, right? So it's fine if you're saying, I'm using that data to make sure that the robot doesn't run into you, right? It's not so good if you're saying, well, actually, I'm using the same data to analyze actually how well you're performing on this task, right? And that might affect actually your employment or your reward and so forth. So that was one of the challenges. The second one that we worked on is the capability side. So we were particularly interested in one of the limitations, which is actually how do you dexterously grasp lots of components? Because often, as you might recognize, a robot needs to somehow interface with the rest of the world. It's just an arm that moves around, right? So the hand is our kind of really kind of important design feature that actually allows us to interact with lots and lots of different objects, but it's very, very complex, right? So then that makes it typically quite expensive or not reliable or a bit of both. So this piece of work actually focused on looking at various different kind of mechanical and soft structures and dexterous structures and control systems that actually allowed us to interface with components. So you see there are actually some structures here that are kind of morphing around, that are deforming around objects that are actually built out of flexible structures. If you want to see them work, we have them still, I think, that we haven't packed up actually in the lab there. It could be things like this where, you know, someone is actually spreading a paste over something, right? This came actually from a study that we did with a food manufacturing company and some other companies in that space, very interesting. And that uses actually dexterous manipulation, so the feeling of how the knife actually moves over the surface in order to control it, right? So that suddenly actually gives you that kind of capability where I don't use that reckoning anymore, right? The robot just follows a path, never mind what happens, but actually reacts to the surface that it interfaces with. The third challenge is more an underpinning challenge, is saying, how do we create the digital infrastructure? So I guess it's a little bit of an interface to what Svetlana was talking about just earlier, is looking and saying, how do we support the development of these systems, right? Recognizing that they will have some learning capabilities, they have some sensing capabilities, and there are some risks involved. So verification and validation becomes a very obvious challenge. And so we looked at various different ways of creating digital systems, and here the biggest challenge are twofold. Is one, how do you bring the physics into it, right? So how do you create environments where forces and torques actually are also present, not just distances, which is relatively easy to do, right? And the second one is, how do we bring in the human behavior, right? So if they interact and I want to verify or validate a system works correctly, I need to have some kind of human that either emulates or interact with that digital system in order to prove that it actually works, right? Or maybe better, you have some kind of avatar or something on this that actually has some kind of human behavior, but then again, we get into challenges about, you know, kind of trying to aggregate human behavior into something that can actually be played back. So there's, again, some interesting ethical challenges there. And then finally, as I mentioned, all of this needs to sit within a kind of a social and cultural understanding of how these new systems, emerging systems, actually affect people on the shop floor. And so we did some studies where we looked at the ethical implications. As I mentioned, ethics before, right? So what are the ethical principles that people might want to follow, both on a shop floor, but also on an organizational level, and potentially societal level, actually, that we need to kind of look at and saying, these are the kind of the rules that govern the game, right? And we did both bottom-up studies where we work with ethicists across Europe to actually see what their opinion is, but we also work with people on the shop floor to actually understand what their specific concerns were actually in this space, and came up with a set of guidelines. In fact, there will be a white paper published on this next week, which will be launched next week. And then finally, as I said, we also did some feasibility projects. So the key element here was to say, how do we translate now some of these technologies in various different ways into different types of applications? So you can see here things from spreading things on toast, right? Using a robot, which for us is trivial, but isn't actually that easy actually to spread it in an even way and evenly distributed, especially if you have, jam that has pieces in, or some kind of, other types of things. And they have different viscosity levels, the bread is different, all of this kind of stuff. Lots of things around digital working. We work with vineyards. That's a vineyard in the UK. Would you believe it? But they were really interested in the digitization element and seeing how they can digitalize their vineyard in order to then test robotic systems within their simulation before they can deploy it, right? So then the challenge was, how do you translate into digital, then use it for verification, and then deploy your system actually back into the environment? And these are just a couple of examples in this space. And I think if I may conclude on this slide, so that gives you maybe a little bit of a flavor. It's been really a pleasure. I mean, the funding is now coming to an end, to work in that space where we could combine the research with some of the application focused projects. And you know, so hopefully there will be future opportunities actually going forwards in this space, but I think we're waiting on some decisions there. So I think, Philippa, over to you if you want to do the questions.
So thank you to you both. So now open the floor to questions. So does anybody want to start? We've got a question over there. Yeah, do you want to give the...
Is this on? Yeah, it's on.
Sure. Hi. Thanks for the presentation. Olushula Mackenzie from Green Tech Fashion. So I've got two questions because I've seen this word a lot and I don't know what it means. What is a cobot? That's my first question.
That's a politically loaded question. No, it's not. I have a very simple answer. It's a nice, convenient marketing term that kind of represents a robot that allows you to share a space. So it's in theory, it's in practice also. Don't get me wrong. They are designed to be safe, to be used among people because it actually has rounded corners and is so low in power, if you like, and moves relatively slowly, so that even if it touches you, it will not actually create any damage. That only holds true, of course, if you don't put a sharp instrument somewhere onto that robot, right? So if you stick a knife at the end of that robot, which is the normal example, or you may have a cutting laser or a cutting torch or something at the end of that robot is no longer inherently safe, right? So, and I didn't mention that in my speech, the thing that I find slightly misleading is none of those robots are collaborative, right? So they coexist. They can be programmed to do tasks around you, but they're not automatically collaborating with anything unless you program it and sensorize it to do so. Yeah, that's very important, but I hope that answers your question.
I was just curious about that word, but anyway, thanks for that explanation. My other question, which relates to my business, is in regards to when will be the right time to start to think about developing a digital factory. So I have created a luxury fashion garment. It's going to be an high-end product. So there's going to have to be a lot of craftsmanship, and I mean highly skilled craftsmanship that goes into the making of it. Of course, well, with what I have designed as well, it's multi-layered, it's removable, it's just got moving parts, it's got lots going for it. At what point should I be thinking about automating my process?
If I can start with the answer, and probably Niels will chip in. Actually, probably the question is not when you need to start. The question is, what is the business case? And any implementation of digital technologies, or any technology for that matter, needs to be driven by business case. And in your case, the business case would be, if you understand, if you analyze your process, are there any parts of the process that you can do more efficiently by introducing some level of digital technology? And if you want to retain the craftsmanship and the craft element, which probably is an essential part of your selling strategy, then you need to understand which elements are not affecting that and can be done better and cheaper by using digital technology. So I wouldn't talk about digital factory. I would talk about probably gradual implementation of digital technologies as required to improve your process, your yield, and to reduce the cost of manufacture.
Okay, before we move on, we've done that already. So as part of our production and sales, we're using immersive tech. We've digitized the garment. So our customers will actually be able to create a product digitally and send it to us. And we thought that was very important to reduce cost, waste, and so on and so forth. So we've done that already.
Yeah. That sounds very good. And maybe that's the right level for you if you want to retain the craft element of the process.
Who else has got a question? A question here.
Hi, I'm Mark Jones. I'm from Connecting for Net Zero. So first thing, I feel like I've gone back in time because I've just realised that both of you were my lecturer at university 20 years ago. So Niels, you've run off from Nottingham, but apart from that, Svetan, you're still in the same place. So my question is I'm from a slightly different sector. So it's about looking at circular economy. And for example, we're looking at a new an aluminium plant in the northeast and how to have a circular economy, energy being a challenge. But the other challenge we face is around skills. So if you were looking at a digital factory, let's say that was in an area that was less developed, what strategies are you putting in place into upskill people around such a complex subject, should we say?
Yeah, if I can start, we have developed a set of training materials, including online materials for digitalization, also supporting step-by-step implementation of digital technologies. You mentioned energy. On the energy side, we have solutions for actually monitoring and optimizing energy at different levels, different resources, different processes. In fact, one of my PhD students who graduated last year already set up his own business, and that business was immediately valued in 3-point-something million, just putting energy monitoring devices and optimizing energy performance with some of the reduction of energy consumption in the range of 20%, which across a factory makes huge difference.
Thank you. Niels?
Well, I mean, it's good to see you, Mark. Surely it wasn't 20 years yet, but it feels like it sometimes. But
no, it really was.
And I mean, so the skills thing for me is two things, right? So one is upskilling, which is obviously is related to what Svetan said in terms of training and so forth, which is really important. On the other side, of course, you can kind of go and say, how do we wrap technology in a way that makes it more accessible so that people that have different skills, right? So they're maybe more practical or, they have a, process knowledge, but they're not necessarily IT specialists, actually can deploy those technologies in a way that actually still achieves their purpose. Which is where a lot of the assistance functions now come in, potentially where some of the smart tools and learning tools can come in and where you say, actually, these adaptations can actually be now observed from data, for instance, and adapted and so forth, right? And whether that's always an answer, I don't know, but it certainly provides some of the answers.
Can I just add to that? I mentioned our apps approach. So with that, what we're trying to do is capture manufacturing knowledge and allow you with less understanding or less skills to just download that, load it on your device, and that automatically configures it and executes operations. So that's another way to really deal with the skill challenge.
Thank you. Cheers.
Have I got another mic? I'm just going to pass over.
Hi, thank you. Antonio Rosales from Industrial Robotic Solutions. My question is mostly related to being a robotic startup. Once you are at a certain level in your development, once you've done a couple of pilot runs or test runs, and you see the benefit of having a digital twin to test and to perfect and to improve your system, how would you recommend going about that? Which approach would you take? Because sometimes as a small startup with few people in it, you might not find the time to do absolutely everything you need to do, even though some of these things, like having a digital twin for your solution, might be at the top of the priority, as it would actually have a lot of benefits in terms of improvement for your system.
Again, we need to be careful because the cost of developing a digital twin, it could be quite high. So then the question is, what are the benefits of that? And if that gives you benefits in terms of coming with better solutions or reusing that digital twin on a number of times for different applications, then it makes sense. If it is just a digital twin that is not going to deliver the value, then probably you don't need it. To be very much on the practical side, if we forget about the excitement around it, practically you always need to make a case for what does it take to have a digital twin.
If I can just add to that, it might be just, let's say, to ramp up that, if you're at a, let's say, 70% accuracy level, something like that, you want to ramp up to that 90%, and doing actual physical tests might involve more time in terms of development, putting up the test and everything. It could be a bit faster in a digital simulation. So that's sort of like the place we're at right now, if it's worth to do it.
Absolutely, and digital twin that is being updated as well from the physical environment, continuously updated, and then you can test and do variety of different scenarios there. This is when it makes sense. I mean, I always give the example of Formula One when they change tires. They go through about 5,000 different scenarios before they decide when to change the tires, and it makes sense. So you have a lot of applications like this in manufacturing where digital twin definitely delivers value.
Maybe if I can add to this, I mean, you need maybe also look at, you know, as I think as Svetlana said, actually your specific application. So I think one of the things we found at least is that the physics engine of most of the, and I say specifically simulation, I'm a little bit hesitant to say that actually what you're talking about is necessarily a digital twin. But I think what you're talking about is maybe some kind of simulation and verification before you actually deploy your system. The challenge is that they often work for rough validation of your program. So if you want to check the basic logic of what is going on, that works well. As soon as you have physical interactions where, you know, you're maybe trying to understand what is the effect of different noise variations in geometry or, you know, contact conditions, the friction changes and so forth, none of this is actually well embedded into simulation yet. So if you want to go to that level, at the moment, the effort to do so would far outweigh the benefits that you would get.
Thank you very much.
Any more questions? No, so thank you to you both. And I suppose it's probably an open invite is that you've both got facilities that people can visit.
Yes, absolutely.
So if any of the things that you've seen kind of in this talk have resonated with you, please kind of get in touch with Svetlana and Neil. So yeah, thank you very much, and hopefully see you all at the awards night this evening.